Welcome, friend. Find a comfortable position, let your shoulders soften, and let your breath slow down. Tonight, we're traveling very, very far away, to the gentle outer edge of our solar system, where a small, quiet world called Pluto dances slowly with its faithful companion, a moon named Charon. Pluto lives in a region of space called the Kuiper Belt, a vast, icy neighborhood beyond Neptune where the sunlight arrives faint and soft, like the last glow of a candle in a distant room. Out there, it is always twilight, a deep, peaceful dusk that never quite ends. And in that eternal evening light, Pluto drifts, patient, unhurried, in no rush at all. But Pluto is never truly alone. Beside it always is Charon, a moon so large compared to its parent that astronomers sometimes call them a double world. Charon is more than half the size of Pluto itself, which makes their partnership unlike almost any other in our solar system. They are less like a planet and its moon, and more like two old friends walking hand in hand through the dark. And their dance is truly a slow one. While our own moon circles the Earth each month, Charon takes an entire week to complete one gentle loop around Pluto. Everything out there moves at the pace of a long, restful sigh. Pluto itself takes nearly 248 Earth years to travel once around the Sun. Think of that. A single Pluto year lasts longer than several human lifetimes. It is a world that knows nothing of hurry. Here is the loveliest part of their story. Pluto and Charon have become what scientists call tidally locked. Over countless ages, their gravity gently tugged at one another, slowing them down, calming them, until now each world shows only one face to the other forever. Charon hangs motionless in Pluto's sky, never rising, never setting, a constant, familiar presence, like a nightlight that never turns off. And from Charon, Pluto appears equally still. A quiet companion fixed in the heavens, they gaze at one another endlessly, a slow, tender waltz that never ends and never needs to end. In 2015, after a journey of more than 9 years, a little spacecraft named New Horizons sailed past this distant pair and sent home pictures that took our breath away. We saw Pluto up close for the very first time, and it was beautiful. Its surface glowed with soft plains of nitrogen ice, including a vast, smooth, heart-shaped region now known as Tombaugh Regio. A gentle heart, written in frost, on a world at the edge of everything. Charon, too, revealed its quiet character. Its face bears a large reddish-gray cap at its north pole, a region scientists affectionately nicknamed Mordor Macula. But there is nothing frightening about it, only ancient ice, touched over eons by faint sunlight, painted in muted shades of rust and rose. Charon's surface is crossed by long, smooth plains and deep canyons, some far larger than any canyon on Earth, carved slowly, patiently, across billions of quiet years. Imagine standing there, if you will, on the icy plains of Charon. Above you, Pluto hangs enormous and serene in the black sky, 3/4 of the heavens filled with its soft, pale face. You would see its heart-shaped plain shining faintly, lit by a sun so far away it looks like just another bright star. The silence would be absolute, deep, and perfect. Snow like frost beneath your feet, stars unblinking above, and nowhere, anywhere, a single sound to disturb the peace. This slow dance has been going on for over 4 billion years, before there were trees on Earth, before there were oceans, before our planet had even finished forming. Pluto and Charon were already turning together in the dark. They will keep dancing long after we are gone, long after our sun grows old, steady and unhurried, two small lights keeping each other company in the immense quiet. And perhaps there is a gentle lesson in that. Even in the coldest, darkest, most distant corner of our solar system, there is companionship, there is constancy, there is a kind of quiet devotion written in gravity and ice. Pluto and Charon do not rush, they do not strain, they simply turn, together, at exactly the pace the universe allows. So as you drift now towards sleep, picture them, two small worlds, far beyond the reach of any noise or worry, circling one another in soft, silent grace. Let their patience become your patience. Let their stillness settle into your breathing. The universe holds them gently, and it holds you too. Rest now and let the slow dance of Pluto and Charon carry you softly into your dreams, where the night is long, the stars are kind, and everything moves at just the right pace. Good night. Hello there and welcome. And tonight we drift far, far from home, past the quiet planets we know so well, all the way out to the very edge of our solar system. To Neptune, the great blue world where the wind sings faster than sound itself. Settle in now, make yourself comfortable, and let us begin our slow journey outward. Beyond Saturn's gentle rings, beyond Uranus tilted on its side, rolls the eighth planet, Neptune. It is so distant that sunlight, which touches your face in just 8 minutes here on Earth, takes more than 4 hours to reach it. By the time that light arrives, it is faint and thin, a soft silvery glow, like moonlight that never quite fades. From that faraway shore, our sun looks like little more than a very bright star. And yet, on this cold, dim world at the edge of everything, something remarkable happens. The winds blow faster than anywhere else in the entire solar system. Faster, in fact, than sound travels here on Earth. Imagine that for a moment. Here at home, the fastest hurricane winds might reach 250 kilometers per hour, fierce enough and yet familiar. But on Neptune, winds have been measured at over 2,000 kilometers per hour, nearly twice the speed of sound. If you could stand, safely, in the upper clouds of Neptune, the wind would carry you around the planet in barely 16 hours. Even though Neptune itself takes almost 165 Earth years to circle the Sun once. Why, you might wonder, does this faraway world, so cold and so quiet-looking, whip up the fastest winds we know of? The first reason is the cold itself. That may sound strange, but Neptune's atmosphere is made mostly of hydrogen and helium, with a touch of methane that gives it that lovely deep blue color. In the thin, frigid upper atmosphere, these gases move with very little resistance. The air is thin and chilled, so it takes surprisingly little energy to push it to tremendous speeds. It is rather like how a light feather skims along on a gentle breath, while something heavy needs a mighty gust. The second reason lies deep below the clouds. Neptune, unlike the Moon or Mars, still has a great deal of heat stored inside it. In fact, it radiates more than twice as much energy as it receives from the distant sun. That inner warmth rises slowly through the atmosphere, stirring the gases, feeding the weather, keeping the atmosphere in gentle, constant motion. Astronomers are still unraveling the details of where all that heat comes from. A slow, ancient warmth left over from the planet's birth, 4.5 billion years ago. The third reason is simply distance and stillness. Out there is little to slow the winds down, no large continents to break them apart, no mountains to snag them, no friction to wear them out. Once the atmosphere begins to spin and swirl, it just keeps going, like a marble rolling across a vast, smooth sheet of ice. And here is where our story gets its name. On Earth, sound moves through the air at about 1,200 kilometers per hour, a speed set by how quickly molecules of air can bump into one another and pass a vibration along. Neptune's winds surge past that speed. They outrun their own sound. If a storm raged on Neptune, the wind could carry itself across the sky before its roar could arrive at your ear. The wind, you might say, arrives before its own song. Of course, nobody has ever stood on Neptune to listen. The planet is a world of gas and ice, with no solid ground to stand upon at all, just clouds drifting through deeper and deeper layers of atmosphere down toward a strange, hidden interior of hot, dense fluids. Everything we know comes from a brief, beautiful visit. In 1989, when the little spacecraft Voyager 2 sailed past on its long, quiet journey and sent home the first close-up pictures of those blue clouds and their racing streaks, it saw a great dark spot, a storm as wide as our entire Earth, before it slipped away into the deepening dark. Since then, telescopes like Hubble and now the James Webb have kept a soft, patient watch on Neptune, watching its clouds bloom and fade with the seasons, each season lasting over 40 Earth years. So tonight, as you drift towards sleep, picture it gently, a deep blue world in the far, cold silence, wrapped in winds that race faster than their own sound, carrying invisible songs across a sky no human ear has ever heard. a quiet, beautiful mystery at the edge of the sun's domain, patient, serene, and waiting for us whenever we are ready to dream our way there. Sleep well now, and let the winds of Neptune sing you softly to rest. Welcome back, dear dreamer. Settle in, get comfortable, and let your shoulders soften. Tonight we drift far, far away from Earth, beyond the warm, familiar glow of our own sun, out to the coldest, quietest corners of our solar system, where something truly magical happens. We are traveling to the ice giants, Uranus and Neptune, the two great blue worlds at the outer edge of everything we know. And there, deep beneath their calm, serene surfaces, it rains diamonds. Let us begin our gentle journey. Imagine, if you will, leaving Earth behind. As we rise above the clouds, our blue planet shrinks to a marble, then a speck, and then it is gone, folded into the vast dark velvet of space. We drift outward, past Mars, past the swirling bands of Jupiter, past the golden rings of Saturn, and onward for years and years of travel, until we arrive at Neptune, the eighth world from the Sun. From this distance, the Sun is only the brightest star in the sky, a distant lantern casting pale, cool light across everything. Neptune hangs before us like a deep sapphire, smooth and beautiful, glowing softly in blues and teals. It looks so peaceful from up here, like a calm ocean, frozen in time. And it is peaceful in its way. But hidden beneath those lovely clouds is one of the most wonderful secrets in all of astronomy. We could slip quietly beneath Neptune's outer atmosphere, descending through layer after layer of hydrogen and helium gas. We would find the pressure slowly building, gently at first, then more and more, thousands of times the pressure of Earth's atmosphere, then tens of thousands. The temperature rises too, not the gentle warmth of a summer day, but thousands of degrees of heat, hot enough that matter begins to behave in very strange, very beautiful ways. And here is where the magic begins. Down in those deep, dark, crushing layers, the ice giants carry enormous amounts of methane, a simple molecule made of carbon and hydrogen, the same molecule that makes these worlds look blue. As the methane is pushed deeper and deeper, squeezed by unimaginable pressure, heated by unimaginable warmth, the molecule begins to break apart. The hydrogen drifts away, and the carbon, the humble carbon, is left behind, compressed together by the weight of an entire planet. And carbon, when it is squeezed just so, becomes diamond, tiny crystals at first, sparkling in the darkness, and then larger and larger as more and more carbon presses together. Scientists believe this happens on both Neptune and Uranus, those two quiet, distant siblings, and they have even recreated small pieces of this process here on Earth, in laboratories, using powerful lasers to briefly mimic those deep, intense conditions, and in those brief flashes, diamonds formed. Real diamonds, born from plastic, just as they are born slowly and endlessly inside the ice giants. So imagine now, you are floating there in the deep interior of Neptune, where no spacecraft has ever gone and perhaps never will. Around you in the hazy, glowing dark, countless diamonds are forming, and as they form, they grow heavy, heavier than the soft, flowing material around them. And so they begin to fall, slowly at first, drifting downward like the first snowflakes of a quiet winter evening, and then steadily, gracefully, descending through thousands of kilometers of deep blue darkness, a rain of diamonds, falling silently forever onto the strange, dense heart of the planet, where the pressure is so great that the diamonds may melt into exotic oceans of liquid carbon, perhaps even forming seas of shimmering liquid diamond, with solid diamond icebergs floating gently on top. Like ice on a midnight lake, is that not a beautiful thought? A world where the most precious gemstones on Earth, the stones we craft into rings and treasures, fall like common rain, ordinary and endless, no one to admire them, no one to name them, simply falling in perfect silence for billions of years, and Uranus, tilted on its side, rolling slowly around the sun like a sleeping ball, hides the same quiet wonder within, two blue worlds, calm and distant, each one secretly snowing diamonds in its deep interior. There is something deeply soothing about this, I think, while we sleep here on Earth, while the rain patters softly on our windows and the night wraps around us. The universe continues its slow, patient work. Stars burn, galaxies turn, and on two faraway worlds, diamonds drift down through the dark like gentle snow. No hurry, no noise, no worry. Just the universe quietly making beautiful things, whether anyone is watching or not. So tonight, as you close your eyes, let your mind drift out past the moon, past the sun, past all the familiar stars, to two blue worlds glowing softly in the distance. And picture those tiny crystals falling gently, endlessly through the deep, quiet dark. Breathe in slowly and out, and let yourself drift like a diamond in the dark, gently, gently, down into sleep. Good night, dear dreamer. Good night. Tonight we drift quietly out-drifted, past the moon, past Mars, to visit a gentle giant and its shimmering crown of ice. Saturn, the jewel of the solar system, and the story of how its rings whisper across billions of kilometers of space. Close your eyes if you like, and imagine a world 9.5 times wider than our own Earth, a great sphere of pale gold, wrapped in bands of soft cream and butterscotch clouds. Around it turns a circle of light, thousands of ringlets, each one a stream of icy fragments, some as small as grains of sand, some as large as houses, all gliding together in an endless, patient dance. The rings look solid from far away, like a smooth disk of silver, but they are not solid at all. They are a sea of snow and ice, so thin in places that if you could press them flat against a planet, they would be thinner than a sheet of paper. Billions of pieces of ice, each following its own quiet orbit, each one reflecting sunlight back into the darkness. And here is the secret of the whisper, because the rings do not only sit quietly, they speak. Every fragment of ice pulls gently on Saturn with its tiny gravity, and Saturn pulls back, and the rings pull on Saturn's moons, and the moons pull on the rings. All this quiet tugging sends vibrations, waves, rippling through the ring material like wind moving across the surface of a pond. These waves are called density waves, ridges of tightly packed ice that spiral slowly around the ring plane, rising and settling again, over and over, for millions of years. These gentle waves do not stay contained, they reach out, because everything in the solar system is connected by gravity, the softest and most patient force of all. Saturn's rings tug on the inner moons, shaping their orbits, keeping them in tidy, resonant patterns like dancers holding hands. Mimas, Enceladus, Tethys, small icy moons that bob and sway in rhythms set in part by the ring system itself. And the whisper travels even further. Saturn's great magnetic field, a bubble of invisible influence, sweeps through the rings and carries electric currents up along invisible field lines, connecting the rings to the planet's poles. In Saturn's far north, near the top of the world, faint auroras glow, ribbons of soft green and violet light, nudged in a small and delicate way by the ring system below. The rings, in their own quiet language, paint light onto the planet's sky. Even here near Earth, Saturn's presence is felt, in the tiniest, most tender of ways. The pull of Saturn, along with Jupiter, gently influences the long, slow wobble of Earth's orbit over hundreds of thousands of years, a rhythm woven into our planet's ancient ice ages. We are all part of one great, quiet gravitational conversation, and Saturn's rings are one of the voices in it. The rings are also slowly, gently speaking to Saturn itself. Little by little, over millions of years, the rings are raining down onto the planet. Tiny icy particles, charged by sunlight, slide along magnetic field lines and drift downward, a soft, constant snowfall of ring matter into Saturn's clouds. Scientists call it ring rain. It is not a loss, it is a gift, the rings slowly sharing themselves with the world they encircle. And where did the rings come from? Perhaps from a moon that wandered too close long ago and was tenderly unmade, spread into a halo of shining pieces. Perhaps from a comet that drifted near and dissolved into ice. We do not know for certain, and that mystery is part of the rings' gentle magic. They are a memory written in frozen light. The spacecraft Cassini spent 13 years listening to these whispers, circling Saturn, dipping between the rings and the planet itself. In its final months, it passed through the gap again and again, tasting the ring rain, measuring the quiet gravity of the rings, hearing in its instruments the soft hum of a system in balance. So tonight, as you drift towards sleep, picture it all. A pale gold world turning slowly in the dark, a crown of ice shining with borrowed sunlight, waves of gravity rippling outward, touching moons, touching auroras, touching faintly even us. Nothing in the solar system is truly alone. Everything leans gently on everything else. And Saturn's rings are one of the loveliest examples of that quiet connection. The whispers continue always, patient, soft, and endless. Rest now, and let the rings shine gently in the background of your dreams, circling, circling, in the calm and beautiful dark. Hello and welcome. Settle in, find your most comfortable position, and let your shoulders soften. Tonight, we drift far from Earth, to a world where time itself moves a little strangely. Our destination is Venus, the second planet from the Sun, our closest planetary neighbor, and one of the most curious clocks in the entire solar system. Imagine for a moment standing on Venus. The sky above you glows in soft shades of amber and gold, thick with clouds that stretch endlessly in every direction. Below your feet, the ground is warm and smooth, shaped by gentle volcanic plains that have rolled out across the planet for millions of years. And here is the wonderful mystery of this place. If you stood there and waited patiently for the sun to rise again, you would wait longer than an entire Venusian year. Yes, that is true. Venus takes longer to spin once on its axis than it does to travel all the way around the sun. Its day, its slow, dreamy rotation, lasts about 243 Earth days. Its year, one full loop around the sun, takes only about 225 Earth days. So on Venus, the day outlasts the year. A day that is longer than a year. Doesn't that sound like something from a sleepy, drifting dream? Why does Venus move this way? Astronomers believe that billions of years ago, Venus may have spun much more quickly, like Earth does now. But Venus is wrapped in a tremendously thick atmosphere, a blanket of clouds so dense and heavy that it presses down on the surface with great, steady weight. Over countless ages, the slow tides of that enormous atmosphere, pulling gently against the planet itself, acted like invisible fingers, softly, patiently slowing the spin. Like a hand gently slowing a spinning top, until Venus now turns at the pace of a slow, deep breath. And there is another quiet wonder. Venus rotates backward compared to most planets. If you could hover above it and watch, you would see it turning clockwise, while Earth turns counterclockwise. Scientists think this may be the result of ancient collisions during the solar system's chaotic youth, or perhaps the same atmospheric slowing simply carried the spin gently past stillness into reverse. Whatever the cause, Venus remains the calm contrarian of our planetary family, content to move at its own pace, in its own direction. Now, because of this slow, backward spin combined with its swift orbit, something lovely happens to time on Venus. If you measured a solar day from one sunrise to the next, it would take about 117 Earth days. So in one Venusian year of 225 Earth days, the sun rises only about twice. Imagine that, a whole year passing, with just 2 dawns. Every sunrise on Venus would feel like a rare, precious event. A golden moment that arrives slowly and is treasured long. From the surface, though, you would never actually see the sun as a bright disk. The clouds are too thick for that. Instead, the light would arrive as a soft, diffuse glow, like standing outside on a heavily overcast afternoon when brightness fills the whole sky without any single point of light. The sun would simply warm one side of the sky, and hours later, very slow hours, the glow would drift away. There is a peaceful quality to that image, I think. A sky without sharp shadows. A world of gentle, even light. Astronomers have learned all of this slowly too, patiently over decades. Radar signals have been bounced off Venus's surface, revealing its mountains and valleys beneath the clouds. Spacecraft have drifted past, peeked through the haze, and even landed briefly, sending home pictures of a strange, beautiful landscape of flat stones stretching to a hazy horizon. Each measurement of Venus's rotation has refined our understanding. Until today, we know its sluggish spin down to moments of precision. And as our own planet spins beneath us now, carrying you gently through the night, it's comforting to think of Venus up there, turning so very slowly, in no hurry at all. While you sleep, Venus will rotate only a small fraction of a degree. While a full night passes on Earth, Venus barely blinks. It is the universe's most patient clock. keeping time in long, slow measures like a lullaby played at half speed. Perhaps there is a small lesson in that for us. Life does not always need to move quickly. Some things, some days, some seasons, some restful nights are meant to unfold slowly. Venus reminds us that even a planet can take its time, drifting through its orbit, turning at its own gentle rhythm, unhurried and serene. So close your eyes now if you haven't already. Picture that soft amber sky, the slow-moving glow, the long, lazy turn of a world that outlasts its own year. Let your breathing slow to match it, in and out, calm and steady, like the rotation of Venus itself. Rest well, the stars will keep watch, and Venus will keep its slow, gentle time all night long. Tonight, let us drift far, far away from Earth, past the Moon, past Mars, across millions of miles of quiet, starlit space, to visit a place of remarkable patience and beauty. We are traveling to Jupiter, the largest planet in our solar system, and there on its vast, banded face, we will find something truly wonderful. A storm so old, so enduring, that it was swirling before many of the nations of our world even existed. It is called the Great Red Spot. Imagine, for a moment, a storm wider than the entire Earth. If you could place our whole planet inside it, with its swirling clouds and its winds, there would still be room to spare. The Great Red Spot is not a small weather event like the storms we know on Earth. It is an enormous, gently churning vortex, a vast oval of rust-red and cream-colored clouds, spinning slowly and steadily in Jupiter's southern hemisphere. It has been spinning, as far as we know, for at least 350 years, and perhaps much, much longer. Think about that for a moment. 350 years ago, on Earth, people were sailing wooden ships across the oceans, lighting their homes with candles, looking up at Jupiter through the very first simple telescopes. And even then, in the 1600s, astronomers like Giovanni Cassini recorded a curious spot on Jupiter's face. It may well have been this very same storm, continuing its slow, patient dance all this time, while empires rose and fell. While generations were born and grew old, the Great Red Spot simply kept turning, calm in its own way, persistent and unbothered. Now you might wonder, how can a storm last so long? On Earth, hurricanes form over warm oceans, and when they drift over land or into cooler waters, they weaken and fade away, usually within days or weeks. But Jupiter is a very different world. It is a giant planet made mostly of gas. There is no land for a storm to collide with, no mountains to break up the winds, no solid ground at all. Jupiter is wrapped in layer upon layer of clouds, hydrogen and helium, ammonia ice and colorful hazes, stretching down into depths we have never seen. And so, a storm on Jupiter has nothing to stop it. It simply spins, carried along by the planet's winds, fed by the gentle, endless flow of the atmosphere around it. The Great Red Spot rotates counterclockwise, completing one full turn about every 6 Earth days. Its winds at the edges blow faster than any hurricane on our planet, hundreds of kilometers per hour, and yet from far away it looks peaceful, like a great slow whirlpool of paint, stirred into Jupiter's creamy bands. The colors themselves are beautiful, soft shades of brick red, salmon, and dusty orange, likely painted by sunlight acting on the chemicals in the clouds above. Though scientists are still gently unraveling that mystery. And here is something quietly remarkable. The Great Red Spot is changing, slowly, over decades. It has been shrinking. Once it was wide enough to hold 3 Earths side by side. Today it is closer to the width of just one, still enormous, still majestic, but gradually becoming more compact and more rounded, like a ball of dough being softly kneaded. Whether it will continue to shrink or settle into a smaller, steadier form, scientists watch with patient curiosity. There is no need for worry. Even if it continues its slow transformation, it will likely endure for a very long time, perhaps long after we are gone, a quiet constant in our solar system. Humanity has sent its finest eyes to visit this ancient storm. In 1979, the Voyager spacecraft sailed past Jupiter and sent home breathtaking images of the spot, revealing delicate swirls and eddies within it, like the cream folded into coffee. Later, the Galileo orbiter watched it for years, And more recently, the Juno spacecraft, still circling Jupiter today, glides over the pole on its long, looping orbits, peering down through the clouds. Measuring the depth of this great vortex, which reaches hundreds of kilometers beneath the visible surface, far deeper than anyone had guessed. So tonight, as you settle into sleep, let your mind rest beside this gentle giant. Picture it, a vast, warm-toned eye on the face of a distant planet, turning slowly in the dark, as it has for centuries, as it will for centuries more. While you dream, it will still be there, unhurried, unchanged in its nature, a reminder that the universe holds things of extraordinary patience. The stars keep their quiet watch, Jupiter turns serenely through the night, and its great red storm goes on spinning softly as it has since long before any of us, and perhaps long after. Let that vast, slow calm carry you gently now, into rest, into sleep. Good night. Tonight, let us drift far from Earth, farther than the moon, farther than the sun, out to a quiet world where snow falls in silence. We are traveling to Mars, and specifically to its gentle polar caps, where winter has been falling for millions of years. Imagine the journey. Mars turns slowly beneath us, a rust-colored sphere wrapped in a thin, whisper-thin atmosphere. There are no bustling cities down there, no glowing highways, only vast plains of dusty red, ancient canyons, and the tallest volcano in the solar system sleeping under a soft veil of haze. And at the very top and very bottom of this world, two shimmering crowns of ice, waiting patiently through the seasons. Let us glide down toward the North Pole first. As we descend, the landscape below begins to change. The red gives way to pale creams and whites, like frosted lace spreading across the planet. This is Planum Boreal, the northern ice cap, a dome of frozen water and dust, layered like a very old cake, each layer recording a chapter of Martian history. Scientists who study these layers can read them the way you might read the rings of a tree, each one a gentle note about winters long past. And here is the secret that makes this place so special, something that took humanity many decades to discover. In the deep of Martian winter, when the northern cap is tucked in darkness, something extraordinary happens. Carbon dioxide, the same gas that fizzles in your sparkling water, freezes out of the thin air. It becomes a delicate frost, and then, impossibly, it falls as snow. Snow made of frozen air itself. Imagine standing there if you could, wrapped warmly in imagination, of course, watching this snowfall. The flakes would be tiny, finer than anything on Earth, drifting down through air 100 times thinner than ours. And here is the most wonderful part. The snow would make no sound at all. On Earth, snow muffles the world, softening footsteps and hushing the streets. But on Mars, the air is so thin that sound barely travels. The snowfall would be utterly, completely silent. Snow falling in a hush deeper than any hush on our world. NASA's orbiting spacecraft have watched this happen from above. They've seen the ice cap darken and swell as winter arrives, watched frost creep outward like slow-moving lace. And in recent years, delicate instruments caught the faint telltale shimmer of carbon dioxide snowflakes drifting near the pole. The first snowfall ever witnessed on another planet. A quiet discovery, a gentle wonder. Now let us travel south to the other crown of ice. The southern cap is colder, older, and it keeps its secrets a little differently. Here, buried beneath the frozen carbon dioxide, lies a vast reservoir of water ice. So much of it that if it ever melted, it could cover the whole planet in a shallow sea. Beneath the shimmering surface, there may even be small pockets of salty brine, lingering liquid, tucked away in the deep cold. The southern cap holds another treasure, CO2 ice that persists through the summer, never fully melting away. It has built up over thousands of years, carved by wind into terraces and pits that look, from orbit, like the surface of a grandmother's quilt. Soft spirals and gentle grooves, patterned by slow, patient forces. And then when spring returns, the frozen air wakes. Sunlight seeps through the translucent ice, warming the ground beneath. The carbon dioxide below turns to gas, and softly, the ice above begins to vent. Geysers of dust and gas rise in slow plumes, fanning dark streaks across the surface like spider webs of light and shadow. Not violent, just the planet breathing out its long-held winter breath, ready to begin the cycle again. There is something deeply peaceful about all of this. Mars is a world without hurry. Its seasons stretch nearly twice as long as ours because its year is longer. Its winters arrive slowly and leave slowly. The snow falls without wind's complaint, without city noise, without a single footstep to disturb it. It is perhaps the quietest snowfall anywhere. Snow that falls in a silence so complete it almost hums. And yet this frozen world is not so different from home. The water ice at Mars's poles is made of the same simple molecules as the ice in a winter pond on Earth, frozen hydrogen and oxygen arranged in delicate crystals. If an explorer ever walks there someday, they will crunch across snow that is, in its heart, an old familiar friend. Snow from another sky, but snow all the same. So tonight, as you settle into your own warm bed, let your mind linger on those distant polar caps, twin crowns of ice at the top and bottom of a rust-red world. Picture the fine flakes drifting down through the thin, still air, falling and falling, without a whisper, without a sound. The silent snowfall continues, season after season, whether anyone watches or not. The universe, it seems, keeps its gentlest wonders in the quietest places. Rest now and let the silence of Martian snow carry you softly into sleep. Tonight we drift far from Earth, out across the quiet darkness to visit a small, swift world circling close to the Sun, the planet Mercury, and here on this little sun-scorched sphere, something truly strange happens at sunrise. The sun rises, then it pauses, and then it slowly slides backward across the sky before continuing on its way. Let us drift together into the gentle explanation of why Mercury's sunrises stop and turn around. Picture Mercury as it truly is. It is the smallest planet in our solar family, a little larger than our moon, and it hugs the sun closer than any other world. A year on Mercury, one full trip around the sun, takes only 88 Earth days. It races along its orbit like a small stone skimming the edge of a warm pond, but Mercury is also a slow turner. While it hurries around the sun, it spins on its axis very lazily. So lazily that a single day-night cycle on Mercury lasts 176 Earth days. 2 of Mercury's years pass during just one of its days. Now here is where the magic begins. On any planet, what we see in the sky comes from a quiet dance between 2 motions. There is the planet spinning, which carries the sun from east to west. And there is the planet moving along its orbit, which makes the sun appear to drift slowly in the opposite direction from west to east against the backdrop of the stars. On Earth, our spin is much faster than our orbital drift, so the sun simply and steadily crosses our sky and we never think twice about it. But Mercury is different. Because it orbits so close to the sun, it moves along its orbit very quickly. And because it spins so slowly, its rotational motion is rather gentle, so the 2 motions are nearly balanced, like 2 soft streams of water pushing against each other. Near certain points in Mercury's year, at what we call perihelion, the closest part of its oval-shaped orbit, the planet's forward motion around the sun grows especially fast. At these moments, the orbital drift becomes strong enough to briefly overcome the spin itself. And so imagine standing on the surface of Mercury, wrapped safely in an imagined suit, watching the sunrise. The sun climbs slowly above the horizon, its light spilling across the grey, cratered plains, but as you watch, it seems to hesitate. It lingers at the edge of the horizon, almost as if it is resting. And then, gently, it begins to slide backward, sinking just a little below the horizon once more, retracing its steps. After some time, it rises again and continues its long, slow journey across the enormous Mercurian sky. What a patient sunrise that would be, lasting hours, unhurried, in no rush at all. There is a lovely rhythm behind all of this. Mercury's spin and its orbit are locked together in a pattern called a spin-orbit resonance. For every 2 trips around the sun, Mercury rotates exactly 3 times on its axis. A 3-to-2 waltz, danced for billions of years. This elegant lock, shaped by the sun's patient tides, is what creates those unusual stretches where the sun's apparent motion reverses and sunrise briefly becomes sunset before beginning anew. Perhaps the most peaceful thought of all, on Mercury you could watch a sunrise that takes its time. The sun, appearing about 3 times larger than it does from Earth, would hover at the horizon, gentle and golden, as the whole slow ballet unfolded above the silent craters. Nothing rushed, nothing urgent, just the calm mechanics of the heavens unfolding exactly as they have for ages. And so Mercury teaches us something soft and reassuring, that even the sky does not always move in one direction. Sometimes it pauses, sometimes it drifts back, gathers itself, and begins again. A small reminder from a small world that it is all right to slow down, to hesitate at the horizon, and to take our time rising. As you close your eyes tonight, picture that slow Mercurian dawn, the golden sun resting at the edge of the world, the quiet stars beyond, and the gentle, endless waltz of a little planet dancing around its star. Let your breathing slow to match it. There is no hurry here, only the vast, calm sky turning softly as you drift into sleep. Welcome, gentle listener. Let us drift far away tonight, farther than you've ever traveled before, to a small, quiet world circling a giant planet, a moon called Europa. Europa belongs to Jupiter, the great king of our solar system's planets. But Europa itself is small, about the size of our own moon, and if you could see it up close, you would notice something remarkable. Europa is covered in ice. Smooth, pale ice, streaked here and there with long, soft lines of rust and cream, like a frozen lake that someone once drew upon with a careful hand. It is, in fact, one of the smoothest objects in the entire solar system. A world that seems to have been polished by time itself. But beneath that quiet, frozen shell lies a secret that scientists have wondered about for decades, and one that still fills them with quiet wonder tonight. Beneath the ice of Europa, there is an ocean. Not a small pond, not a hidden lake, but an ocean, a vast, deep ocean of salty liquid water, perhaps 2 or 3 times deeper than all the oceans of Earth combined. It stretches all the way around the moon, hidden from view, wrapped in darkness, cradled by a shell of ice that may be many kilometers thick. How do we know it's there when no one has ever seen it? Gently, piece by piece, like a detective following soft footprints in the snow. When spacecraft first flew past Jupiter many years ago, they noticed something curious about Europa. Its icy surface was crisscrossed with cracks and ridges, and in some places, it seemed as though pieces of the crust had shifted and drifted apart, like puzzle pieces rearranged, or like ice floes on a polar sea here on Earth. This suggested that something soft, something fluid, was moving beneath the shell, something that let the ice slide and settle. And there was more. Europa hums ever so slightly as it orbits Jupiter. The giant planet's immense gravity gently tugs at the moon, flexing it back and forth, like a slow, patient rhythm. This constant, tender squeezing creates warmth inside Europa, warmth enough, scientists believe, to keep an ocean liquid, even so far from the sun. On Earth, we have places like this too. Deep beneath the frozen Arctic, dark oceans still flow. And around warm vents on the ocean floor, whole communities of life thrive without any sunlight at all. Which leads us to the most wonder-filled question of all. If Europa has liquid water, if it has warmth, if it has the salts and minerals that life on Earth uses as its building blocks, could something be living in that hidden sea, perhaps something small and simple, drifting peacefully in the dark, near warm springs on the ocean floor, swimming in a sea that has never seen the light of day? We do not know yet, and that is all right. Some questions are meant to be held gently for a while. Scientists are preparing a spacecraft, one that has already begun its long, patient journey to fly past Europa again and again, taking careful measurements, listening to the moon, learning its secrets slowly, the way a friend learns yours. Perhaps one day a small craft will land there and melt gently through the ice to peer at last into that hidden ocean. But for now, Europa keeps its secret, as it has for billions of years. It circles Jupiter in silence, wrapped in its frozen blanket, carrying its ocean of possibility in the dark. And there is something comforting in that thought, isn't there? That in our quiet solar system, on a small white moon we can see from Earth with just a pair of binoculars, there may be waves lapping against unseen shores, tides rising and falling under kilometers of ice. A whole hidden world, resting peacefully, waiting patiently to be understood. It reminds us that even in the coldest, darkest places, there can be warmth. Even beneath the hardest shell, there can be softness. And even in silence, there can be life and motion and quiet beauty. So tonight, as you settle into sleep, imagine it for a moment, that small moon far away, turning slowly around its giant planet. Picture the ice, smooth and pale in the dim sunlight. Picture the ocean beneath, deep and still and dark, held safe in its frozen cradle. Somewhere out there, that ocean is dreaming its own long dreams. And you can rest now too, knowing the universe is full of quiet, hidden wonders, patiently waiting, in no hurry at all. Good night, sleep softly, and drift like Europa in perfect peace. Tonight we drift far from Earth, drift farther than the warm sunlight feels comfortable, out to the cold, quiet edge of our solar system. There, circling the great ringed planet Saturn, is a small moon with a very big secret. Its name is Enceladus, and it is one of the gentlest wonders we have ever found. Enceladus is tiny, only about 500 kilometers across. You could fit many of them side by side across the width of our own moon. From a distance, it looks like a smooth white pearl, the most reflective world in our solar system. Its surface is coated in fresh ice, so bright and clean that it gleams like new snow under a winter sun. And this little moon has something extraordinary hiding beneath that icy shell, an ocean. Yes, an ocean. Deep below the frozen crust, warmed quietly by the gentle squeezing of Saturn's gravity, lies a vast sea of liquid water. It has been there for billions of years. Dark, calm, and hidden, no sunlight reaches it. And yet, it may be one of the most promising places we know of to look for life. Here is the most beautiful part. Enceladus shares its secret with anyone who cares to look. Near its south pole, great cracks split the ice, long, elegant fissures that scientists nicknamed tiger stripes. Through these cracks, the little moon breathes. Geysers of water vapor and tiny ice grains rise up, soft, towering plumes that stretch hundreds of kilometers into space. Some of that icy spray falls gently back to the surface like snow. Some escapes entirely, drifting outward to join a faint, hazy ring around Saturn called the E-ring. In a way, Saturn wears a shimmering halo made partly of Enceladus. In 2005, a spacecraft named Cassini arrived at Saturn after a long journey across the solar system. And as it sailed past this small moon, its instruments noticed something surprising. Saturn's magnetic field lines bent gently around Enceladus, as if something were flowing from it. Then the cameras confirmed it, geysers glittering in the distant sunlight. Cassini would go on to fly through those plumes many times, sampling them directly, like catching snowflakes on your tongue. And what did it find in that frozen spray? Water, of course, but also salts and simple organic molecules, the kinds of carbon-based ingredients that on Earth are part of every living thing. There was even molecular hydrogen, a whisper of chemical energy suggesting that warm water and rock meet and interact on the seafloor below. It is not proof of life, not at all. But it tells us that Enceladus has everything life would need if it chose to exist there. A liquid ocean, nutrients, and warmth, however gentle. Imagine that for a moment, a small moon bathed in the pale glow of Saturn's rings, quietly sending up fountains of its hidden sea as it has done for ages. It does not shout, it does not hurry, it simply breathes, ice crystals catching the distant light like dust motes in a sunbeam. Scientists love Enceladus for another reason too. Because the plumes bring the ocean's water up through the cracks and into space, we do not need to drill through kilometers of ice to study that hidden sea. The moon delivers its secrets to us, free of charge, suspended in icy grains, drifting patiently across millions of kilometers. It is as if the little moon were leaving us small gifts, invitations to keep looking, keep wondering. Someday, perhaps within your lifetime, new spacecraft will visit. Missions are already being dreamed up and designed, probes that will fly again and again through the plumes, searching for more complex molecules, perhaps even signs of something alive. If anything ever swims or drifts in that dark ocean, we may one day know its name, or at least know it is there. But for now, Enceladus keeps its secret softly. It spins quietly around Saturn once every day or so, reflecting sunlight like a tiny lantern, spraying a fine mist of its ocean into the black, joining the slow, elegant dance of the rings. And isn't that a comforting thought to fall asleep to? That out there, right now, in the cold silence between the stars, a little moon is breathing, gently, steadily, sharing its hidden sea with the universe, one soft plume at a time. The cosmos is vast, but it is not empty. It is full of quiet wonders, patient and beautiful, waiting for curious minds, just like yours, to keep asking questions. So close your eyes now and drift off the way Enceladus drifts around its giant planet, slowly, peacefully, held safe in the quiet of the night. Good night, sleep well, and dream of oceans beneath the ice. Close your eyes now and let your thoughts drift upward, past the ceiling, past the clouds, past the quiet veil of night, all the way to the sun, not the bright, waking sun of daytime, but the sun as it truly is, a vast, glowing ocean of light and sound, humming softly in the darkness of space. For the sun is not silent, it never has been. Deep within its golden body, enormous waves rise and fall, waves far too vast, too slow, and too deep for any ear to hear. Scientists call them oscillations, but tonight, let us simply call them the sun's song. Imagine, if you will, standing at the shore of an endless sea at dusk. The waves arrive one after another, unhurried, each one rolling beneath you with a rhythm older than memory. The sun is like that sea, but instead of water, its waves are made of pressure and heat, moving through rivers of glowing gas, plasma, brighter than anything we could look upon and live, yet gentle in its own way, steady, patient, eternal. These waves begin deep inside, in the sun's blazing heart, where the temperature burns at millions of degrees. Their energy is born, tiny fragments of light slowly working their way outward, like bubbles rising through honey. It can take 100,000 years, sometimes more, for a single packet of that energy to reach the surface. All that time, it pushes and pulls at the sun's interior, and the sun responds, gently swaying, breathing, ringing like a bell made of starlight. And just as a bell has a tone, a deep, resonant voice, so does the sun. Astronomers have listened with careful instruments, watching the sun's surface rise and fall by just a few kilometers, a breath, barely a ripple on something so immense. And from those tiny movements, they have pieced together its music. If we could speed it up, if we could shrink 400,000 kilometers of glowing gas down to something the size of a drum, we would hear a low, mysterious hum. A chord played on an instrument the size of 100 Earths. But the sun keeps its song at a pitch far below hearing. Its deepest waves take hours, sometimes days, to complete a single rise and fall. A sound so slow is not a sound at all to our ears. It is more like a tide, like the way night follows day and day follows night. The sun hums on a timescale that asks nothing of us, that demands no attention, that simply continues, whether we listen or not. There is something deeply comforting in that. All your life, the sun has been singing above you. It sang before you were born, through every century, every age, every quiet night in history. While you sleep tonight, it will still be there, on the other side of the turning earth, humming its patient song into the dark. Waves rolling through its depths, the way calm rolls through a peaceful mind. And the sun's music is not merely beautiful. It is useful too. Just as a doctor might listen to your heartbeat to learn about your body, scientists listen to the sun's waves to learn what lies beneath its glowing surface. Each wave travels a different path, some skimming near the surface, some plunging deep toward the core, and by tracing their journeys, we have mapped hidden rivers of plasma flowing beneath the sun's skin. We have learned how it turns on its axis. how its warmth is stirred and mixed. The song is the sun telling us its secrets, softly, slowly, in its own time. Think of it now as you drift towards sleep. 150 million kilometers away, a star breathes. Its surface shimmers with waves 1,000 kilometers tall, yet so gentle they would be invisible unless you knew to look. Inside, sound waves curl and echo, bouncing through oceans of light, ringing again and again in patterns that have repeated for billions of years, and will continue long after tonight is over. The planets ride through this music like boats on a still lake. The Earth turns within it, and you, warm and safe in your bed, are held in your own quiet way inside that same great rhythm. Every sunrise you have ever seen is the sun's song arriving on time. Every spring, every summer afternoon, every golden evening, all of it moves to the same slow, deep pulse. So let your own breathing fall into that rhythm now, in and out, slow as a solar wave, deep as starlight. There is no hurry. The sun has been humming for 4.5 billion years, and it does not need you to listen. It simply sings for the joy of the cosmos, for the turning of the planets, for the peace of all who rest beneath it. Let the waves carry you now, farther, softer, slower, as the sun hums on, too deep to hear and too gentle to disturb, and let yourself drift at last into sleep. Tonight, we drift gently toward one of the quietest wonders in the universe, a star called a red dwarf. Imagine the night sky as you've always known it. The bright stars that catch your eye, the ones sailors once steered by, are the loud, brilliant ones. They burn fast and hot, like candles consumed in a single evening. But scattered all around them, far too faint for our eyes to see, are the true champions of patience, the red dwarfs. Red dwarfs are the smallest and coolest kind of true star. Where our sun blazes at thousands of degrees, a red dwarf glows more softly, a deep ember orange, like the last warmth of a fireplace late at night. The smallest of them are barely larger than Jupiter, our solar system's giant. If our sun were a warm bonfire, a red dwarf would be a single, steady candle flame, modest, quiet, and remarkably enduring. And here is their secret: they are in no hurry at all. A great, brilliant star burns through its fuel the way a fire races through dry kindling. The brightest stars in the sky will shine for only a few million years before gently fading away. Our own sun, steady and generous, will last around 10 billion years, but a red dwarf sips its fuel. It burns so slowly, so carefully, that it can continue shining for trillions of years. Think about that for a moment. The universe itself is only about 13.8 billion years old. That means not a single red dwarf anywhere in all of creation has yet reached old age. Every red dwarf that has ever existed, every one you could point a telescope toward tonight, is still young, still in the earliest chapter of an unimaginably long story. Why do they last so long? It comes down to something beautifully simple: convection. In a red dwarf, the star's interior slowly stirs, like a pot of soup simmered on the lowest possible heat. Fresh fuel is gently circulated from the outer layers down into the core, where it can be used. Nothing is wasted, nothing rushes. The star simply keeps going, unhurried, glowing dimly and faithfully for eons beyond counting. There is a lovely consequence to this patience. When red dwarfs finally do exhaust their fuel, trillions of years from now, they will not explode or erupt. They will simply cool, little by little, fading into quiet, dense remnants, slowly dimming into darkness like a lamp turned down on its gentlest setting. Even their endings are peaceful. And red dwarfs are everywhere. Though you cannot see a single one with your naked eye, they are believed to make up the great majority of all stars in the universe. 3 out of every 4 stars you would find among the galaxies are red dwarfs, hidden in plain sight, glowing faintly in the deep. Our closest stellar neighbor, Proxima Centauri, just over 4 light-years away, is one of them. When you look toward the southern constellation of Centaurus, you are looking in the direction of a tiny, patient star. One that will still be shining, calmly and steadily, long after the sun has completed its own long journey. Some of these little stars are surrounded by planets. Astronomers have discovered worlds circling red dwarfs, rocky planets tucked close to their dim warmth, close enough that liquid water might gather on their surfaces. Around a cooler star, the gentle habitable zone lies nearer in, where a planet could bask in soft, perpetual twilight. Imagine a world bathed in the amber light of a red dwarf, a sky the color of a sunset that never quite ends. Warm enough for oceans, lit by a star that will keep that gentle glow for trillions of years. Of course, red dwarfs have their moods. Some flicker now and then with small flares, brief brightenings like a candle guttering softly in a draught. But even this is part of their character, a little restlessness in an otherwise enormously long and steady life. So as you settle in tonight, consider the red dwarf. In a universe full of movement and change, where galaxies slowly turn and brilliant stars bloom and fade, the red dwarf simply endures. It does not dazzle. It does not hurry. It glows quietly at the edge of visibility, holding its warmth, saving its strength for a future so distant we can scarcely picture it. Long after every bright star has burned out, long after the galaxies have drifted and dimmed, the red dwarfs will still be there, the last little lights of the universe, keeping their slow, faithful watch. Patient stars, outliving everything. Let that thought carry you now softly towards sleep, like a small warm light glowing far away in the dark. Steady, calm, and there for a very, very long time. Good night. Tonight we drift far from our swift blue world, out past the planets, past the soft clouds of the Milky Way's edge, to meet a very old and very gentle giant. Its name is Betelgeuse. You may have seen it already without knowing. On clear winter evenings, look up toward the constellation of Orion, the hunter. At his shoulder glows a warm, reddish-orange star. That is Betelgeuse, watching over us as it has watched over countless generations of dreamers before. Betelgeuse is what astronomers call a red supergiant, and the word giant is not an exaggeration, not even a little one. If we placed Betelgeuse where our sun sits now, its glowing surface would stretch beyond the orbits of Mercury, Venus, Earth, and even Mars. The entire inner solar system would rest comfortably inside the star, wrapped in its warm, amber light. It is one of the largest stars we know of, a truly enormous presence hanging quietly in the night. And yet, for all its size, Betelgeuse is not still. It moves, it swells ever so slightly, and then it settles again, slowly, patiently over years. Astronomers have measured this gentle rhythm with great care. The star brightens a little, then dims. It expands a fraction, then contracts, like a sleeper's chest rising and falling in the quiet of night. Betelgeuse breathes. Why does a star breathe? Well, to understand, we must look deep inside, into the heart of this cosmic giant. Stars shine because at their cores, they fuse lighter elements into heavier ones, releasing tremendous energy. Our sun burns hydrogen into helium, a steady, patient fire that has lasted billions of years. But Betelgeuse is far larger, and it burns its fuel much more quickly, living a shorter but far more brilliant life. Deep in its core, it has already woven together heavier and heavier elements, building toward iron, the point where stellar alchemy can go no further. Because Betelgeuse burns so furiously, its interior is a churning, roiling sea. Energy fights its way outward from the core through vast convective currents, rivers of hot gas rising, cooling, and sinking again on a scale beyond imagining. These currents are enormous. Where the sun has a fairly calm layer keeping its surface steady, Betelgeuse's outer layers are turbulent, bubbling like a slow-motion ocean. And as those great bubbles of hot gas rise and fall, the star's surface itself gently inflates and relaxes. This is called pulsation, and it is the breath of Betelgeuse. The star's brightness rises and falls in rhythms of many months, one long cycle, another even longer one, layered over each other like slow waves in a calm sea. Long ago, ancient peoples noticed this star's shifting glow and wondered at it. Today, we know it is simply a star finding its balance. Gravity pulling inward, heat and light pushing outward, the two great forces negotiating softly and endlessly. In recent years, Betelgeuse gave astronomers a moment of quiet surprise. In 2019 and 2020, the star dimmed more than anyone had seen in living memory. Some wondered if it was preparing for something dramatic, but careful study revealed something far gentler. The star had coughed out a large cloud of dust and gas, a quiet burp of material drifting into space, and that cool veil momentarily blocked some of its light. Not an ending. Just a giant adjusting itself in its sleep. Betelgeuse soon brightened again, and it continues its slow, steady breathing to this day. One day, many thousands or perhaps hundreds of thousands of years from now, Betelgeuse will run out of fuel in its core, and it will end its life in a supernova, a final, luminous exhale that will briefly shine as bright as a moon in our sky. But that is a story for the far, far future. For now, the giant is content. It has been burning for perhaps 10 million years, and it has plenty of time left. More time, in truth, than all of human history stretched out 1,000 times over. There is something comforting in this thought. A star so immense, so ancient, so powerful, moves through its long life with patience. It swells and softens, it brightens and rests. It sheds a little dust into the dark and keeps shining. Its rhythm is a reminder that even the largest things in the universe live gently in their own time, without hurry. So tonight, if the sky is clear, you might glance toward Orion's shoulder and give a small nod to the giant. It is there, as it always is, breathing its slow breath, swelling and settling across light years, its light traveling 600 years just to reach your eyes. And as you close your eyes to sleep, you can imagine that rhythm, in and out, vast and calm and steady. Let your own breathing match the giant's if you like, slow and soft and deep. The universe, it turns out, is not in a rush. Neither are you. Rest now, beneath the watchful glow of Betelgeuse, the gentle giant who breathes among the stars. Welcome back, friend. Let the room grow dim, let your shoulders soften, and drift with me now, out beyond the familiar stars, to visit some of the quietest places in the universe. Tonight, we are learning about white dwarfs, the gentle embers left behind when stars complete their long lives. Imagine a star like our own sun. For billions of years, it burns steadily, fusing hydrogen into helium in its warm, glowing heart. It is a slow, patient fire, one that asks for nothing and gives light to everything nearby. But no fire lasts forever. Slowly, over unimaginable stretches of time, the fuel runs low. The star swells gently, sheds its outer layers into space like soft silk scarves drifting on a breeze, and what remains at the center is a white dwarf. A white dwarf is small, really small for a star. It's about the size of our Earth, yet it holds nearly the mass of the Sun, packed into that modest sphere. If that sounds impossible, it's because white dwarfs live by unusual rules. There is no fusion burning inside them anymore, no roaring furnace. Instead, they are supported by a strange and beautiful quantum pressure, a kind of deep stillness in the matter itself, where electrons refuse to be squeezed any closer together. It's as if the star has found a way to rest, while remaining utterly, perfectly intact. And here is the loveliest part. White dwarfs are not dying in any dramatic sense. They are simply cooling very, very slowly. When they are young, they glow a brilliant white, hot beyond imagining. Over billions upon billions of years, they dim, shifting from white to yellow to orange, and eventually, in a future so distant it makes the current age of the universe look like a single afternoon, they will fade to black. Astronomers call these future objects black dwarfs. Though the universe isn't old enough yet for a single one to exist, every white dwarf that has ever formed is still glowing, faintly, patiently, like coals in a hearth long after the fire has settled. Our own sun will become one of these embers someday far from now, roughly 5 billion years in the future. That may sound like a long way off, and it is, reassuringly so. When it happens, it will be a gentle process on cosmic timescales. The sun will swell briefly, release its outer atmosphere into a shimmering cloud called a planetary nebula. A misnomer, really, since it has nothing to do with planets. And then settle into its long twilight as a white dwarf, glowing softly over the worlds it once warmed. Many white dwarfs are already visible to us, if you know where to look. The nearest one is Sirius B, a faint companion to the brightest star in our night sky. Hidden in Sirius's brilliant glare, this little ember has been quietly cooling for over 100 million years. Astronomers needed powerful telescopes just to glimpse it. A small, dense pearl of light drifting through space beside its radiant partner. White dwarfs have other quiet talents. Some of them orbit close companions and gently siphon gas, occasionally brightening in soft, repeating pulses called novae, not explosions of destruction, but brief flares, like a candle catching its breath. Others hold the key to measuring cosmic distances, because certain white dwarf events shine with such dependable brightness that they serve as lighthouses across the universe, helping us map how vast and how old everything truly is. And there is something deeply peaceful about all of this. In a universe of violent collisions and brilliant supernovae, white dwarfs remind us that not every ending is loud. Some endings are slow and soft and full of light that lingers. A white dwarf spends more time cooling than most stars spend alive. Its afterglow will outlast civilizations, outlast continents, outlast nearly everything we know. It simply sits in the dark, radiating the last warmth of a life well spent. Asking for nothing, disturbing nothing. So the next time you look up on a clear night, remember, scattered among those bright, burning points of light are countless unseen embers, ancient hearts of former stars, resting quietly in the dark. They have been there for billions of years, and they will be there long after tonight, long after every worry you carry has faded from memory. Let that thought settle over you now like a warm blanket. The universe is patient, the stars know how to rest, and so can you. Close your eyes, breathe slowly, and drift off, knowing that somewhere far away, a small white ember is glowing softly, keeping a gentle watch over the night. Good night, sleep well, and rest among the quiet stars. Tonight, let us drift together into the quiet dark of space, where some of the strangest and most gentle-hearted objects in the universe are quietly keeping time, like old lighthouses watching over a sleeping sea. Far away in the soft blackness between the stars, there are objects called neutron stars. They are the remnants of enormous suns, stars that once burned bright and warm, and then, after a very long and peaceful life, gently let go. When such a star reaches the end of its journey, its outer layers drift away into space, forming beautiful, slow-swirling clouds of color, and the heart of the star remains behind, small and dense, quietly settling into itself. A neutron star is remarkably small, only about the width of a city, perhaps 20 kilometers across. Yet within that tiny sphere is packed more matter than our entire sun holds. Imagine that, a whole sun's worth of substance, folded into something you could walk across in an afternoon, if walking there were possible. Everything about it is calm and still on the outside, but it holds a quiet, incredible strength within. And here is where our lighthouse story begins. When these old stars settle down, they begin to spin, not quickly and chaotically, but steadily, smoothly, like a figure skater drawing in her arms and gliding in a perfect, endless turn. Because the star has become so small and compact, its spin becomes wonderfully fast. Some of them turn around completely many times every single second. A heartbeat, and the star has already made a full circle. Another heartbeat, another circle. It is the most patient waltz in the universe. Now a neutron star also carries a magnetic field, a magnetic personality, you might say, far stronger than anything near Earth. And because of this, the star sends out narrow beams of radio waves from its two magnetic poles, two slender threads of light and energy streaming out into the darkness from opposite ends of the star. But here is the lovely part. The magnetic poles are not quite the same as the star's spinning axis. They are tilted just a little, the way a child's top leans gently as it spins on a rug. So as the star turns, those two beams of light sweep around and around, like the beam of a lighthouse sweeping across the harbor, around and around and around. If you happen to be standing in just the right place in the universe, the beam sweeps over you once each time the star turns. Sweep, a pulse of light, sweep, another pulse. And that is exactly what astronomers here on Earth noticed long ago, steady, rhythmic little signals arriving from deep space, ticking like clocks. At first, they were so regular that some wondered if they might be messages, but the truth turned out to be even more beautiful. They were simply the heartbeat of the stars themselves, turning quietly in the dark. These spinning lighthouse stars earn the name pulsars, which simply means pulsing stars, and each one keeps its own rhythm. Some pulse slowly, once every few seconds like a slow, deep breath. Others flicker many hundreds of times each second, humming like a soft, steady note held in the air. Astronomers have learned to love these rhythms because pulsars are the most faithful timekeepers we know of. Some of them have kept their beat perfectly for millions of years, never early, never late. Patient beyond imagining. Think about that for a moment as you settle deeper into your blankets. Somewhere far above you, right now, there are stars spinning gently in the darkness, sweeping their soft beams across the galaxy, keeping perfect time. And they have been doing so since long before there were any eyes on Earth to notice. And they will continue long after tonight is over. There is something deeply comforting in that, isn't there? The universe is full of quiet constancy. The tides rise and fall on schedule. The moon makes its slow circles. The stars turn in their patient dances. And somewhere out there, a lighthouse star is sweeping its beam across a sleeping galaxy, marking the seconds of a night that has lasted millions of years. And the very first pulsar ever discovered. The astronomers playfully named it LGM-1 for Little Green Men as a small joke before they understood what it was. But soon they knew better. It was no visitor at all, only a star doing what stars do, turning slowly, shining steadily, asking nothing of anyone. So tonight, as your eyes grow heavy and your breathing slows and deepens, let your mind rest on that image. A small, dense star, no bigger than a city, turning gently in the velvet dark. Its two soft beams of light sweeping round and round like a lighthouse watching over a calm sea, steady, unhurried, perfectly at peace. Let that rhythm follow you down into sleep, sweep and sweep and sweep. The universe is keeping watch tonight. You are safe to rest, sleep well, and drift gently like starlight into your dreams. Tonight, we drift slowly through the quiet vastness of space to visit a place of gentle beginnings. Far from any city light, hidden among the dark ribbons of the galaxy, there are vast clouds where new suns are born. Astronomers call these places stellar nurseries, and they are among the most peaceful and beautiful sights in the entire universe. Imagine a cloud, not a cloud of water vapor like the soft ones floating over sleepy towns on Earth, but a cloud made mostly of hydrogen, the simplest and most ancient ingredient of everything. These clouds are enormous, stretching for hundreds of light years, and they are incredibly cold, just a few degrees above absolute zero, the lowest temperature that exists. In that deep chill, everything moves slowly, patiently, as though the cloud itself is resting. These molecular clouds are not empty or bright. They are dark and dim, threaded with faint wisps and soft filaments, like smoke from a distant fire, or like the gentle fog that settles over a quiet lake at dusk. And yet, within their stillness, something remarkable is waiting to happen. Because even in a cloud this calm, gravity never truly sleeps. It pulls, softly, persistently, drawing specks of gas and dust a little closer together, bit by bit, over millions of unhurried years. Somewhere deep inside the cloud, a small region grows slightly denser than the gas around it. And as it grows denser, gravity pulls a little harder, and it grows denser still. There is no rush, no violence, just a slow gathering, like snowflakes settling on a windowsill. As this little knot of matter contracts, something wonderful begins. The atoms within it, drifting and jostling gently, begin to move a little faster as the gas is squeezed. And when atoms move faster, the temperature rises. The heart of this nascent star begins to warm, slowly at first, then more and more, until, after countless ages, the core becomes astonishingly hot, tens of millions of degrees. And there, in that hidden, glowing heart, a quiet miracle takes place. Hydrogen atoms, pressed together with unimaginable patience, begin to fuse, becoming helium and releasing light. A new sun ignites, its first rays pushing outward through the surrounding darkness. But the story does not end there. Around many of these newborn stars, the leftover gas and dust, the crumbs of creation, settle into a flat spinning disk, like cream swirling in a slowly stirred cup. And within that disk, tiny grains of dust collide and cling together, forming pebbles, then boulders, then whole worlds. If you are listening tonight from a planet like Earth, then this is how your own home began, inside just such a nursery, billions of years ago. Every atom in your body, every breath you take, was once part of a cloud like this, woven into stars long before our sun was born. The most famous of these stellar nurseries is one you may have seen yourself. High in a winter sky, below the three bright stars of Orion's belt hangs a soft, hazy patch, the Orion Nebula. To the unaided eye, it looks like a faint smudge, a wisp of light, but through a telescope, it reveals itself as an immense glowing cloud, a cathedral of gas and dust, lit from within by hundreds of infant stars. Deep inside, there are places so thick with dust that no visible light escapes. Yet gentle infrared telescopes can peer into those hidden chambers, and there they find thousands of baby stars, each one wrapped in its own little cocoon, slowly warming, slowly gathering itself, preparing to shine. Some of these newborn stars will blaze for billions of years, steady and constant like our own sun, faithfully warming any worlds that form around them. Others, the largest and brightest, will live fast and burn brilliantly, scattering the very clouds that raised them. And in their scattering, they press new clouds together, seeding yet more nurseries, more beginnings. The universe, it seems, is endlessly gentle with its recycling. Nothing is wasted. Everything transforms. So the next time you look up at the night sky and see those countless points of light scattered like grains of sand across the dark, remember that each one began this way. Each sun began as a whisper in a cold, dark cloud, a soft gathering of ancient stardust, patiently warmed by gravity's quiet embrace until it glowed. And as you drift towards sleep tonight, perhaps you can imagine yourself there, floating gently in a stellar nursery, wrapped in soft veils of glowing gas, colors of rose and violet and deep ocean blue, while somewhere nearby, a young star pulses softly, beginning its long, long life. The universe is calm, patient, and full of quiet wonders. Rest now, and let the slow turning of the galaxies carry you gently into dreams, where new suns are always being born, and the night sky watches over you, softly, always. Tonight, as you settle into the youth of your blankets and let your eyes grow heavy, let us drift together into the quiet spaces between the stars and meet some of the loneliest travelers in the universe. When we picture the night sky, we often imagine stars as fixed points, arranged neatly into constellations like furniture in a familiar room. And it is true that most stars are not truly alone. They are born in great families, vast, cloudy nurseries called nebulae, where gas and dust gather over millions of years, folding inward under their own gentle weight until they ignite into newborn suns. The sun itself, the star that warms your face each morning, was once part of such a nursery. Surrounded by hundreds, perhaps thousands, of brother and sister stars, all flickering to life together in the same soft cloud. But families, even stellar families, do not stay together forever. Over time, hundreds of millions of years, the gravity of the galaxy itself gently pulls these sibling stars apart. As they orbit the great spiral of the Milky Way, each star follows its own path, its own quiet circuit around the galactic center. Small differences in speed and direction, barely noticeable at first, add up, year by year, century by century, until the old companions are scattered like seeds on the wind. This is not a tragedy. It is simply the slow rhythm of the galaxy, a dance where partners change and distances grow, and everything moves with patience rather than hurry. And some stars drift much farther than others. Occasionally, a star's journey is shaped by a close encounter. If two stars pass near each other in the crowded heart of a star cluster, their gravitational tides can exchange energy. One star slowed and captured, the other flung outward onto a new path. A star that receives such a gentle cosmic push may leave the galactic disk entirely, wandering into the halo, the vast, dim outskirts of the galaxy. where darkness stretches wide and the neighbors are few and far between. Astronomers call these wandering stars hypervelocity stars when they move quickly, but many more simply drift, unhurried, following long, lonely orbits that may take hundreds of millions of years to complete. There are other wanderers too, stars born small and dim, called red dwarfs, which shine so faintly that even their closest neighbors are invisible to them. And there are the ancient ones, white dwarfs and old, quiet suns that have burned through most of their fuel and now glow like soft embers in the dark, remembering the bright ages when they danced among crowded nurseries. Perhaps the most poignant of all are the rogue stars of the galactic halo, stars that no longer belong to the graceful spiral of the Milky Way at all. Some of these were once part of smaller galaxies that our own slowly absorbed long ago. Their constellations dissolved, their families scattered across the sky like spilled sugar. Now they carry the memory of ancient, vanished galaxies within their quiet light, traveling alone through a galaxy that is not quite their own, yet welcoming them all the same. But here is a gentle thought to hold as you drift towards sleep. A star alone is not a star forgotten. Its light still travels, tirelessly, patiently, across the void. And sometimes that light arrives somewhere wonderful, somewhere it touches a small blue planet and slips through a window and falls softly on a sleeping face. Even a star drifting alone through the darkness is never truly without purpose. Its gravity shapes the space around it. Its warmth may hold a distant planet in a slow, faithful orbit, and its light becomes a quiet beacon, a single point of calm in the immense stillness that anyone, anywhere, may look up and find. So the next time you stand beneath the night sky, perhaps on a cool evening with the world hushed around you, remember that some of those soft points of light have traveled farther than any story can tell. They left their birthplaces among glowing clouds of rose and violet. They said goodbye, slowly and gently, to thousands of siblings. And now they drift through the great dark ocean of the galaxy, luminous, patient, and serene. There is something peaceful in that, isn't there? To know that solitude in the universe is not emptiness, but simply space, room to move, room to shine, room to be. The stars do not hurry, the stars do not worry, they simply drift and burn and glow exactly as they were made to do. And now, little one, let your own light rest. Let your thoughts drift apart like stars released from their nursery, softly, gently, one by one. The galaxy is vast and calm, and it holds everything with perfect patience. Close your eyes and drift like a star into the beautiful, quiet dark. Good night. Tonight we drift slowly, drift far beyond the glow of our own little world, to a place where starlight itself is born. Come with me gently as we float toward the soft glow of the nebulas. Imagine the night sky not as a curtain of black, but as an ocean, vast and quiet, stretching farther than the mind can comfortably hold. And scattered through that ocean, like clouds drifting across a moonlit valley, are the nebulas, enormous clouds of gas and dust, glowing softly in colors that seem almost too gentle to be real. A nebula begins humbly. It is, at first, simply a mist, hydrogen mostly, with traces of helium and fine dust, thinner than any fog you have ever walked through. If you could stand inside one, and you cannot, of course, but imagine it anyway, you would find it nearly empty. The cloud is so sparse that a handful of its material would weigh almost nothing at all. And yet, these clouds are so immense that together, all that near nothing adds up to something extraordinary. Some nebulas stretch across hundreds of light years, regions of space so wide that light itself, moving faster than anything we know, would need centuries to drift from one edge to the other. And here, in these quiet clouds, something wonderful happens, slowly, patiently, in the way of all truly beautiful things. Deep inside the nebula, in its densest folds, gravity begins its gentle work. Little knots of gas, slightly heavier than their surroundings, draw more and more material toward themselves. The knot grows denser, warmer, and as it warms, it begins to glow, first faintly like an ember protected under soft ash. It gathers, it settles, It holds itself together through eons of unhurried time. And then, at last, when the heart of that little knot grows hot enough and dense enough, a star switches on. Its first light spills out into the cloud that made it, illuminating the dust around it in soft pinks and blues and violets. And this is why we call the nebulas stellar nurseries. They are the cradles where starlight begins. Our own sun, the warm, steady light that has watched over every sunrise you have ever known, began this very way. Long before the Earth existed, long before anything we know, there was a cloud like this, and somewhere inside it, a small knot of gas quietly gathered itself into the star we now orbit. Every atom in your body, every bit of iron in your blood, every trace of calcium in your bones, was forged inside ancient stars that bloomed from clouds like these. In a very real, very peaceful sense, you are made of nebula light carried forward across billions of years. Some nebulas glow because newborn stars shine within them, their light reflecting off the dust like lamplight through lace curtains. Others glow on their own, energized by the young stars hiding inside, their hydrogen glowing a deep rose red, like the last soft color of a sunset that never quite ends. And some nebulas do not glow at all. They are dark clouds, visible only as quiet silhouettes against the starfield behind them. Mysterious, patient, waiting for their own turn to kindle new suns. One of the most beloved of these clouds is the Orion Nebula, and you may have seen it yourself without realizing. Find the constellation of Orion in a winter sky, look just below his belt, and there, hanging like a faint, fuzzy star, is an entire nursery of infant suns, 1,500 light-years away. The light reaching your eyes on that quiet night left its home before human history began. It drifted across all that distance, gently, steadily, just to arrive, at last, in your upturned face. And far away in the southern sky, there is the Carina Nebula, even larger, even grander, home to some of the most massive stars the universe has ever made. And there is the Ring Nebula, the soft remnant of a star that, at the end of its long life, exhaled its outer layers outward, a slow, calm breath, leaving behind a ring of glowing gas, delicate as smoke curling in still air. Even the endings in space are gentle. Stars do not slam their doors. They simply release what they no longer need, returning it to the great clouds, where it will gather again, someday, into new suns, new worlds. Perhaps even new oceans, new shores, new sleepy eyes looking up at the sky. So the universe breathes, in and out, over eons, clouds condensing into stars, stars shining, stars returning their gifts to the clouds. Nothing is hurried, nothing is lost. It is the slowest, most patient circle imaginable. And as you rest tonight, you can carry a little of that patience with you, the same calm that shapes a nebula over millions of years, the same unhurried light that travels across 1,000 lifetimes just to greet you, can settle over your thoughts now. Let them drift, like gas in a stellar nursery, loose, soft, unforced. The stars are beginning their journeys tonight, in clouds you will never see but are always quietly connected to. Let that thought hold you, warm and small and safe, as the soft glow of the nebulas carries you gently into sleep. Hello and welcome. Find a comfortable position, let your shoulders soften, and let your breath slow to an easy, gentle rhythm. Tonight, we drift together into the quiet vastness of space to watch something that happens so slowly, so patiently, that it makes the turning of seasons seem hurried. We are going to learn how galaxies slowly spiral toward one another. Imagine first a single galaxy. It is an immense island of stars, dust, and dark matter, hundreds of billions of suns gathered together, turning slowly like a pinwheel of soft light. Our own Milky Way is one of these, and like many galaxies, it is not alone. It has neighbors, and some of those neighbors are, ever so gradually, drifting closer. The most famous example is the Andromeda Galaxy, a great spiral, a little larger than our own, resting about 2.5 million light-years away. If you could see it fully with your own eyes, it would stretch wider than the full moon in our sky. And here is the gentle secret of the cosmos. Andromeda is moving toward us, and we, in turn, are drifting toward it. Now you might wonder, how can galaxies fall toward one another when the universe is so vast and seems so empty? The answer lies in the oldest force of all, gravity. Every bit of matter pulls softly on every other bit of matter. The stars, the gas clouds, and especially the unseen dark matter surrounding each galaxy, all of it adds together, creating a quiet gravitational embrace that reaches across millions of light years, slowly, over unimaginable stretches of time. That embrace draws two galaxies closer. And how slowly does this happen? Andromeda and the Milky Way are approaching one another at about 110 kilometers every second. That may sound fast, and in human terms it is, but on the scale of the cosmos, it is a stroll. The distance between the galaxies is so enormous that even at this pace, the journey will take billions of years, roughly 4 or 5 billion more, before the galaxies truly begin to meet. As the galaxies draw near, something beautiful and curious happens. They do not simply crash into one another. Instead, they begin to dance. Gravity starts to pull at their outer edges, stretching their stars and dust into long, graceful ribbons called tidal tails. These ribbons of stars arc across space like ribbons of light, delicate streams flung outward as the two galaxies circle and approach. And here is one of the most comforting truths of this slow cosmic ballet. The stars themselves almost never collide. Space within a galaxy is far emptier than it appears. Stars are separated by immense gaps, so when two galaxies pass through each other, the stars simply slip past one another, like two flocks of birds mingling in the evening sky. No star meets another. The shapes change, the paths bend, but the stars carry on, shining as they always have. Each time the galaxies pass near one another, they lose a little of their speed. Gravity tugs at them, and that tug carries energy gently away. So they drift apart, but not as far as before. Then they turn and come back, closer this time. Again they part a little less. Again they return. Each pass is slower, each swing shorter, like a pendant swaying on a string, gradually settling. Over hundreds of millions of years, this quiet spiral inward continues, until the two galaxies can no longer pull apart at all. Eventually, the two spirals relax into one. Their swirling arms fade and fold together, and what remains is a single, larger galaxy, calmer in shape, often glowing with a soft, rounded light that astronomers call an elliptical galaxy. Deep in the heart of this new form, the two great black holes that once anchored each galaxy drift closer too, circling one another slowly, until in the far future, they settle together as one. And the night sky, for any observer on a planet in that far-off era, would be a gentle wonder. New constellations, unfamiliar rivers of stars overhead, a soft glow where Andromeda once hung as a distant smudge. There is something deeply peaceful in all of this. The universe is not in a hurry. Galaxies weigh so much and live so long that their slow approach is measured not in years or lifetimes, but in billions of them. Nothing here is rushed. Nothing here is lost. Two vast communities of stars simply move toward one another, guided patiently by gravity over a timescale so generous it feels like rest. So as you settle in tonight, perhaps picture those two galaxies gliding gently closer across the dark. No alarms, no urgency, only the slow, certain pull of a cosmic dance that has been unfolding since long before the Earth was born, and will continue long after we have drifted into dreams. Let that slowness settle over you now. The universe moves at its own pace, and tonight, so can you. Rest well. As you settle into the quiet of this moment, let your eyes soften and your breathing slow, and allow yourself to drift far beyond the ceiling above you, beyond the clouds, beyond even the sky itself, to a place where time moves gently and nothing is ever in a hurry. Tonight, we travel to a quiet corner of the cosmos to listen to a story that has been unfolding for billions of years. A story about two great islands of stars and a meeting still so far in the future that it is less an event and more a promise. You live inside a galaxy. Perhaps you already knew this, but let it settle in now softly. The Milky Way, your home, is an immense, slow-turning spiral of stars, gas, and dust. If you could step outside of it and look back, you would see a luminous pinwheel wider than 100,000 light years, holding hundreds of billions of suns. One of those suns is yours. One of those stars warming a small blue planet is the same one that rises for you each morning. Nestled in a quiet spiral arm, far from the crowded center, in a peaceful suburb of the galaxy. And the Milky Way is not alone. Scattered through the vast darkness are other galaxies, thousands of them, drifting like lanterns on a still black sea. Some are small companions that circle us gently, like the Magellanic Clouds, faint smudges visible from the southern hemisphere of Earth. And one is our great neighbor, Andromeda. Andromeda is a spiral galaxy much like our own, perhaps slightly larger, perhaps holding 1 trillion stars. On clear, dark nights, away from city lights, you can actually see it with your own eyes. A soft, hazy patch of light in the constellation of the same name. That gentle glow is the combined light of 1 trillion suns, traveling more than 2.5 million years just to reach you. When you look at Andromeda, you are looking deep into the past. And yet, tonight, we are going to look into the future. Because Andromeda is moving, very slowly by human measures, and steadily, it is drawing closer to the Milky Way, not rushing, not falling, simply drifting as galaxies do, carried by the quiet pull of gravity across the enormous spaces between them. Astronomers with great care and patience have measured this motion, and they tell us that in roughly 4 to 5 billion years, these two great galaxies will begin to share the same small patch of space, by cosmic standards. But here is the gentle secret of that encounter, the part that makes this story feel more like a lullaby than a tale of drama. Galaxies are mostly empty. The stars within them are so far apart, separated by oceans of nothing, that when two galaxies meet, almost nothing actually collides. Stars will drift past one another like ships in the night, each continuing its own quiet path unperturbed. The sun that warms your world, and the planets that circle it, will almost certainly pass through this meeting untouched. A lone traveler moving through a vast, sparsely populated ballroom. What will change is the shape of things. As the two galaxies approach, their graceful spirals will slowly soften and unwind. Tides of gravity will stretch delicate streams of stars across the darkness, long, luminous arcs like ribbons of light. The two galaxies will pass through one another, perhaps once, perhaps twice, each pass slower than the last, like two dancers drawing closer with every turn, and over hundreds of millions of years, they will settle together. Their stars mingling into a single, serene, elliptical galaxy, a great glowing oval of ancient suns. Some call the result Milkomeda, a quiet blending of two names into one. The night sky, for any observer who might be there to see it, will be transformed, filled with new rivers of stars, unfamiliar constellations, and the warm, diffuse glow of a merged galactic heart. And in the far distance, beyond it all, the rest of the universe will continue its slow, beautiful expansion. Galaxies drifting ever farther apart, like fireflies scattering across an endless meadow at dusk. It is worth pausing on this. 4 or 5 billion years is an almost unimaginable span. The Earth itself is only about 4.5 billion years old. Entire mountain ranges will rise and wear away, continents will drift and rearrange, countless generations of life will come and go, all before this gentle meeting even begins. It is a reminder, perhaps, that the universe is in no rush, that everything unfolds in its own season, slowly, patiently, and peacefully. And so, as you drift now toward your own rest, carried on the rhythm of these words, let this thought settle over you like a soft blanket. You are part of something immense and calm. Two galaxies are journeying toward a meeting so distant that the universe itself considers it unhurried. Nothing needs your worry tonight. The stars are turning as they always have, the spiral arms sweeping through the darkness with the patience of eternity. The Milky Way and Andromeda will meet someday far ahead, and it will be gentle. Until then, there is only the quiet, the drift, and the soft light of 1 trillion distant suns watching over you as you sleep. Tonight, we drift far beyond our little corner of the Milky Way, far past the neighboring galaxies, out into the vast, quiet spaces between. And there waiting for us are some of the largest structures the universe has ever built. Galaxy clusters, Imagine them as floating cities, shining islands of light, held together gently but firmly, suspended in an ocean of darkness. Let us wander slowly through one of these cosmic cities and discover why they hang together at all. First, picture a city on Earth. It is made of many buildings, houses, towers, workshops, all gathered close together, connected by roads and bridges and the quiet hum of shared life. A galaxy cluster is much the same. It holds hundreds, sometimes thousands of galaxies, each one a vast pinwheel or oval of stars, gas and dust, all gathered into a single neighborhood. Our own Milky Way belongs to such a gathering, a modest little town called the local group, but the great clusters, like the Coma cluster or the beautiful Virgo cluster, are true metropolises, millions of light years across. Now you might wonder, in a universe that is constantly expanding, where everything drifts apart like leaves on a slow river, how do these cities stay together? Why don't the galaxies simply float away from one another? The answer lies in an old, familiar friend, gravity. Gravity is the quiet weaver of the cosmos. In the very early universe, regions of space that were just slightly denser than their surroundings, just a touch more crowded with matter, began to pull softly on the matter around them. Over billions upon billions of years, that gentle pulling gathered material together, first into stars, then into galaxies, and then galaxies themselves drifted toward one another, gathering into clusters. These clusters are ancient settlements, some of the oldest communities in the cosmos, places where gravity won its long, patient argument with expansion. Within these floating cities, the galaxies are not still. They move slowly around a shared center, like ships circling a quiet harbor. Each galaxy follows its own graceful path, tugged by the combined pull of everything else in the cluster. And here is one of the loveliest secrets of modern astronomy. When scientists measured how fast these galaxies were moving, they found something surprising. The visible stars and gas simply did not provide enough gravity to hold the cities together. The galaxies should have drifted apart long ago. So scientists concluded that there must be something more, something unseen. They call it dark matter, a vast, invisible scaffolding woven throughout each cluster. It cannot be seen directly, but its presence is felt everywhere, in the way galaxies move, in the way light bends gently around these great masses as it travels toward us. In a way, dark matter is the invisible streets and foundations of the cosmic city. The quiet infrastructure that holds everything in place, while the shining galaxies glow above it like lanterns. And there is more still. Between the galaxies of a cluster, filling all the vast spaces in between, drifts an enormously thin gas, a mist of hydrogen and helium, heated to tremendous temperatures, glowing faintly in X-rays that our eyes could never see. It is called the intracluster medium, a poetic name for the warm breath of the city itself, though it is incredibly sparse, far thinner than any vacuum we can make on Earth. It contains more matter than all the stars in the cluster combined. So when you look at a galaxy cluster, remember, most of its ordinary substance is not in the bright galaxies at all, but in the soft, invisible haze between them. Over immense stretches of time, these cities are never finished. Galaxies occasionally drift too close to one another and merge, slowly, gently over hundreds of millions of years, becoming something new. Clusters themselves gather into even larger patterns, long filaments and walls that stretch across the universe like a luminous cobweb, the largest architecture we know of. And between these threads lie the great voids, enormous, nearly empty rooms in the cosmic house, peaceful and dark. There is something deeply comforting in all of this. In a universe of constant change, gravity provides a kind of loyalty, a promise that once things gather, they tend to stay gathered. Our Milky Way and its neighbor Andromeda and dozens of smaller companion galaxies all rest together in a small town, drifting along filaments of dark matter toward the great Virgo cluster, part of an immense gathering called the Laniakea supercluster, our own cosmic address, written in gravity and light. So tonight, as you settle into rest, imagine those floating cities, thousands of galaxies held softly together by unseen hands, glowing patiently in the dark, their light traveling in silence across billions of years, arriving here just for us to notice. And then, gently, let your own thoughts drift and gather and settle. Good night and sleep well beneath the patient cities of the stars. Tonight, let us drift gently away from everything familiar, past the moon, past the sun, past the soft spiral of our own galaxy, to a place where the universe, in its quiet wisdom, decided to hold almost nothing at all. Astronomers call these places voids, and the one we are visiting tonight is one of the most peaceful and mysterious of them all. A giant cosmic emptiness where galaxies are almost entirely absent. To understand where we're going, it helps to picture the universe as something like a great sponge. When scientists map the galaxies on the largest scales, millions and millions of them, each a vast island of stars, they don't find them scattered evenly like grains of sand. Instead, they find filaments and walls, long, luminous threads of galaxies woven together, and between those threads, enormous open spaces, the voids, the holes in the cosmic sponge. Some of these voids are small, by cosmic standards, just a few tens of millions of light years across, but others are breathtaking in their scale. The largest ones stretch across hundreds of millions of light years, regions so immense that light itself, traveling at its untiring pace, would need an almost unthinkable span of time to cross them. Imagine for a moment standing in the middle of such a place, looking out in every direction. You would see, for the most part, darkness, not the darkness of a cloudy night, but a deeper, softer darkness, the kind that exists between the galaxies. Here and there, far away at the edges, you might glimpse faint smudges of light, distant galaxies like distant lanterns glowing warmly across the emptiness, and between you and them, nearly nothing. A few stray stars, perhaps, flung out from ancient collisions, a whisper of gas, too thin to see, the faint, ever-present hum of the universe itself. It sounds lonely, perhaps, but there is a gentleness to it, a stillness. These voids are not wounds in the cosmos, they are not places where something went wrong, they are simply part of the universe's natural architecture, as much a feature of creation as the brilliant galaxy clusters themselves. And how did they come to be? Scientists believe the story begins in the very earliest moments of the universe, when everything was still a hot, dense soup of matter and energy. Even then, there were tiny differences, places very slightly more crowded, and places very slightly less. Over billions of years, gravity did its patient, unhurried work. The crowded regions drew in more and more matter, growing into the great walls and filaments of galaxies we see today, and the emptier regions slowly, quietly, gave up what little they had. Their matter was pulled outward toward the denser neighborhoods, like water gently flowing downhill. What remained behind was the void, a place defined not by what it holds, but by what it has gracefully let go. One of the most interesting of these regions lies relatively near to us, in cosmic terms at least. Some astronomers studying the structure of our corner of the universe have noticed that our own galaxy, the Milky Way, sits at the edge of a rather large void, sometimes called the local hole or the KBC void. We live, it seems, on the shore of a cosmic emptiness, looking out across it the way one might gaze at a quiet, dark lake from the safety of the land. And being near the edge of a void may even explain some curious things. When astronomers measure how fast our local region of space is expanding, the numbers come out slightly different than expected. Some scientists wonder whether our position beside this great emptiness plays a part, whether the gentle outward flow of galaxies, leaving the void, gives our neighborhood its own subtle character. It is a reminder that even our address in the universe, our little corner of the cosmos, has its own quiet story. There is something deeply calming about these voids once you grow used to them. They are patient places. While galaxies sparkle and burn, forming stars in their crowded, colorful ways, the voids simply rest. They will remain for billions of years yet, growing slowly, almost imperceptibly, as the universe continues its long, unhurried unfolding. And perhaps there is a gentle lesson in them. The universe is not only light and motion and endless busy activity, it is also spaciousness, room to breathe. The darkness between the galaxies is not empty in a sad way. It is empty in a peaceful way, like the silence between notes of music that gives the melody its meaning. So tonight, as you settle into sleep, You can carry this image with you, a vast, soft expanse of cosmic quiet, far away and long ago, holding almost nothing and needing nothing. The galaxies glow at its distant edges like nightlights in a great dark room, and at its center, perfect stillness. The universe, it turns out, knows how to rest, and so, in its gentle company, so can you sleep well. Tonight, let us drift together toward one of the quietest wonders in the universe, a place where time itself slows down and bends, gently, like a leaf settling on still water. Far across the cosmos, beyond the stars you can see from your window, there are enormous objects called black holes. You may have heard that they are frightening, places where nothing escapes. But tonight, we will think of them differently. We will imagine the calm ones, the slowly spinning black holes, massive, patient, and serene, floating in the deep dark like stones resting at the bottom of a peaceful lake. A black hole forms when a very large star reaches the end of its long life. For millions of years, that star burned steadily, holding itself together with its own warmth. But eventually, like a candle finishing its final flicker, the star grows tired. Its outer layers drift away softly into space, and its heart, its very center, collapses inward, folding into itself until it becomes something extraordinary. A region of space where gravity is so tenderly strong that even light pauses in its journey. Now here is where the story becomes truly beautiful. Almost everything in the universe spins. Stars spin, planets spin, and when a star collapses into a black hole, it keeps that gentle turning, like a figure skater drawing in their arms and gliding ever more smoothly across the ice. Some black holes spin slowly, calmly, completing one graceful rotation over long stretches of time, and this slow, steady turning changes everything around them. You see, a spinning black hole does not simply sit in space like a perfect sphere. It drags the very fabric of space and time along with it, the way a spoon stirring honey draws the honey around in a soft, lazy swirl. Scientists call this frame dragging, a lovely phrase for such a gentle phenomenon. Space itself begins to flow around the black hole, curving and bending in smooth, quiet spirals. And time bends too. Near a black hole, clocks tick more slowly than they do far away. If you could hover at a safe distance and watch a friend's spaceship drift closer, you would notice their clock moving slower and slower, their light growing warmer, softer, stretching into deep reds. Nothing dramatic happens, no alarms, no chaos, just a gentle slowing, as though the universe itself were yawning, settling in for a long and restful evening. This is not imagination. It is real physics, described by Einstein's theory of general relativity, the idea that mass and movement shape the space and time around them, the way a heavy sleeper gently curves the mattress beneath them. Time bends slightly even here on Earth. Satellites far above our planet experience time a tiny fraction differently than we do, and engineers must account for it quietly every day. Around these calm, spinning giants, matter sometimes gathers into a disk, a soft, glowing ring of gas and dust, like cream swirling into dark tea. As the material circles, it glows with gentle light, golds and oranges against the deep darkness. And above and below, some of it escapes as quiet jets, slender beams of light stretching for thousands of light years, like the slow exhalation of a sleeping giant. Imagine floating, at a peaceful distance. Before you, the black hole appears as a perfect circle of deepest darkness, framed by a luminous ring bent around it. Because the space is curved, you can see stars that are actually behind the black hole, their light bent around the edges, arriving at your eyes from paths you would never expect. The universe becomes a hall of soft mirrors, everything gently warped, gently rearranged. And the spinning, the slow rotation stirs everything into long, elegant arcs. Light traces ribbons around the darkness. Time stretches thinner the closer you drift. If you could orbit there for what felt like a single afternoon, decades might pass elsewhere in the universe. Whole civilizations rising and resting, stars forming and fading, all while you floated in your own private stretch of slowed, syrupy time. Astronomers have found these objects scattered throughout the cosmos. Some, millions of times heavier than our sun, sit at the centers of galaxies, including our own Milky Way, where a quiet giant named Sagittarius A star rests about 26,000 light-years away. It spins slowly, it waits. It shapes the orbits of stars around it like a patient conductor, guiding a very, very slow symphony. There is something deeply comforting in all of this. The universe is not only fire and collision and noise, it is also stillness, patience, objects that bend time itself, yet do so with the gentleness of a slow-turning carousel under evening lights. So as you settle in tonight, let your own sense of time soften. Picture that dark, serene circle far away, space curling around it in silent spirals, seconds stretching longer and longer the nearer you imagine yourself, until time feels as wide and slow as a calm, starlit sea. The universe knows how to rest. And now, so can you. Tonight, we drift gently into the quiet depths of the universe to listen to something very old and very, very low. Far beyond our sky, at the centers of enormous galaxies, there sleep giants called supermassive black holes, and remarkable as it may seem, they sing. Not with sound as we know it, of course. Space is mostly empty, a near-perfect silence, with too little air to carry a melody to our ears, but sound is simply a wave, a ripple of pressure traveling through a medium, and deep in the hearts of galaxy clusters, there is a medium after all. A thin, wispy sea of hot gas, drifting between the stars like mist over a midnight lake. In 2003, astronomers pointed a quiet eye toward a galaxy cluster called Perseus, a soft gathering of thousands of galaxies floating some 250 million light-years away. At its heart sat an enormous black hole, and around it that faint cosmic haze. Using the gentle light of X-rays, scientists studied ripples in the gas and found something wonderful. Those ripples were waves, pressure waves, sound waves, rolling outward from the black hole like rings spreading across still water. And what a note it was. The pitch of these waves was extraordinarily low, 57 octaves below middle C. That is a sound far, far deeper than any human ear can perceive, deeper than the lowest note of a pipe organ, deeper even than the deepest rumble of a distant thunderstorm. If our ears could somehow hear it, it would be less like a song and more like a single, endless hum, a bass note sustained for millions of years. Why so low? It comes down to size and to time. Here on Earth, sound waves are small and quick, vibrating through air many hundreds of times each second. But a supermassive black hole is unimaginably vast, millions, sometimes billions of times the mass of our Sun. As it feeds, drawing in swirling gas and dust, it sends out jets and gusts of energy from its poles, like slow, patient breaths. Each of those breaths pushes a wave into the surrounding gas, and because the black hole is so enormous, each breath takes millions of years to complete. A wave that's slow is a wave that is wonderfully, impossibly deep. There is something soothing in that thought, isn't there? While our lives unfold in minutes and hours, these giants hum on a timescale where a single note outlasts mountains, oceans, entire ages of the earth. And these songs are not merely curiosities. They do quiet, important work. The waves carry energy, and as they spread through the hot gas of a galaxy cluster, they gently stir it, keeping it from cooling and collapsing too quickly. In a way, the black hole's low hum is like a slow lullaby for its whole galaxy, regulating the temperature, pacing the birth of new stars, maintaining a long and delicate balance. Astronomers sometimes call it feedback. A gentle conversation between a galaxy and the giant at its heart. In more recent years, scientists have listened even further. Using delicate instruments tuned to the ticking of distant, spinning stars called pulsars, nature's most precise clocks, researchers have detected a faint, rippling tremor woven through spacetime itself. A background hum, perhaps created by countless pairs of supermassive black holes, slowly circling one another throughout the universe, each pair adding its own deep voice to an unending cosmic chorus. So the universe is not silent after all. It is filled with music, just at pitches we were never built to hear. The night sky above you holds orchestras of these low, patient songs, waves rolling through invisible seas of gas, humming across millions of light years, older than any living thing on Earth. Somewhere right now, a black hole at the center of a distant galaxy is breathing out its slow pulse. A note that began before there were words and will continue long after. Not a roar, not a thunder, just a deep, endless tone, steady as a heartbeat measured in eons. And as you settle into sleep tonight, you can imagine yourself wrapped in that sound, resting within a universe that hums softly to itself in the dark. The galaxies drift, the stars shine quietly, the giants sing their one long note. Let your breath slow to match it, deep and slow and calm. Good night and pleasant dreams beneath the humming sky. Tonight, let us drift gently towards one of the quietest places in the universe, a place where space itself draws a soft, invisible line. Astronomers call it the event horizon, and though it sounds mysterious, it is not a door and not a wall. It is simply a boundary like the edge of a lake at dusk, where one kind of world ends and another begins. To understand it, we must first think about black holes, gently and without fear. A black hole forms when a very large star, far larger than our own sun, reaches the end of its long life. The star, having burned warmly for millions of years, finally grows tired. Its great weight presses inward, 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 until all of its matter is gathered into a point so small and so heavy that space itself curves around it completely. Imagine a soft blanket stretched across your bed. If you place a small marble on it, the fabric dips just a little. Place a heavy stone, and the dip grows deeper. A black hole is like a stone so heavy that the blanket folds all the way down into a smooth, endless curve. Light itself, the fastest traveler in the universe, cannot climb back out of that curve. And that brings us to the event horizon. It is not a thing you could touch. There is no surface there, no shimmering curtain, no gate. It is simply the distance from the center of the black hole beyond which nothing, not even light, can return. Below that line, every path a beam of light could take leads inward. Above it, light and matter and information can still wander freely through the cosmos. The horizon is the quiet dividing line between these two possibilities. That is why we say it is a boundary, not a door. A door invites passage in both directions. A boundary simply marks where the rules change, the way the shoreline marks where the land ends and the sea begins. The sea does not pull at you with intention. It simply follows its nature, and the shoreline tells you where its nature begins. Size of this boundary depends on the black hole itself. A black hole with the mass of our sun would have an event horizon only a few miles across, a surprisingly small circle for something so profound. But the enormous black holes that sit at the centers of galaxies, and nearly every large galaxy has one, including our own Milky Way, can have horizons millions of miles wide. The one at the heart of our galaxy, called Sagittarius A star, is about 4 million times the mass of the sun. And yet it rests so far away, 26,000 light years, that it touches nothing in your world tonight. It drifts through its own slow orbit, patient and still. You may wonder what it would be like to watch something approach this boundary. Picture a small spacecraft drifting in, or better yet, a gentle beam of light. To us, watching from far away, that light would appear to slow as it neared the horizon, its color stretching gradually toward deep red. And then it would seem to pause there, growing ever fainter, like a candle across a foggy valley. It would never quite appear to cross. Time, near the horizon, stretches and softens, the way an evening seems to lengthen when you are peaceful and unhurried. And what of the horizon itself? In 2019, humanity saw, for the very first time, the shadow of a black hole's horizon, a dark circle ringed by glowing gas, captured by telescopes linked together across the whole Earth. It was a quiet miracle of patience and cooperation. Scientists listening to the sky, gathering whispers of light, and slowly forming a picture of something once thought unknowable. There is a gentle comfort in these ideas. The event horizon does not rage or roar. It is silence given shape, a place where the universe simply agrees that some things go inward and some things go free. Around it, stars still circle in slow, graceful orbits, the way moths trace soft loops around a lantern. Galaxies spiral onward. The universe is not troubled by its black holes. They are part of its rhythm, as the deep parts of the ocean are part of the sea. So tonight, as you settle into your pillow, let your thoughts rest on that quiet boundary, a line drawn not in fire or stone, but in the soft geometry of space itself. Not a door that slams, not a wall that blocks, just a gentle edge where light lays down its burden and the universe exhales. The stars will keep their distance, the horizon will keep its silence, and you can drift off now, safely home, while the great dark circles of the cosmos turn slowly, peacefully in the distance. Sleep well. Tonight, let us drift quietly through the cosmos and consider one of the universe's slowest, most patient stories, the story of how black holes grow. It may seem strange to think of a black hole as patient. We often imagine them as cosmic vacuum cleaners, endlessly devouring everything around them. But the truth is far gentler and far slower. And in that slowness, there is a kind of peace. Picture a black hole floating in the deep dark between the stars. At its center lies a point of infinite density, wrapped in an invisible boundary called the event horizon. Anything that crosses that boundary, light, dust, the occasional wandering star, never returns. And yet, despite this fearsome reputation, a black hole spends almost all of its existence waiting, because the universe, you see, is mostly empty. Around a typical black hole, there is simply nothing, no planets drifting too close, no stars straying into its grasp, just the vast, quiet emptiness of interstellar space, stretching outward in every direction. For a black hole to grow even a little, matter must come to it, and matter in the cosmos is astonishingly rare. Our own sun, burning steadily for billions of years, converts only a tiny fraction of its mass into light. A black hole must gather mass the slow way, particle by particle, atom by atom, through the gentle rain of interstellar gas, through faint cosmic dust, through the rare and meandering approach of a star that has wandered, over millions of years, just a little too near. There is another beautiful reason for this slowness, one discovered in the mathematics of Einstein's relativity. As matter falls toward a black hole, it does not simply drop in like a stone into a well. Instead, it spirals, circling closer and closer, like water finding its way down a vast and gentle drain. As it spirals, it heats up, glowing with X-rays and light, and in its glowing, it pushes back. Radiation presses outward against the infalling gas, slowing the feast. This delicate balance, which astronomers call the Eddington limit, acts like a natural speed governor on every black hole in existence. Even a black hole that sits amid plenty, surrounded by a rich cloud of gas, can only eat so fast before its own glowing meal pushes the rest away. So black holes grow, but slowly, so slowly. The supermassive giant at the center of our Milky Way, a monster 4 million times the mass of our Sun, has taken billions of years to reach its size, and it continues to grow at a pace so gentle that across the entire span of human history, it has barely changed at all. Sagittarius A star, as we call it, drifts quietly at the heart of our galaxy, having its rare and modest meals, mostly asleep. And yet, the eons are long. The universe has time. In the first billion years after the Big Bang, some black holes somehow grew to enormous sizes, and astronomers still wonder gently about how they managed it. Whether they were born large from the collapse of ancient, massive stars, or whether they found unusually rich feasts in the young, crowded universe. Even then, growth was measured in millions of years, not moments. There is a strange comfort in this. The universe's most powerful objects are also its most unhurried. A black hole does not chase. It does not strain. It simply sits at the center of its own quiet gravity and lets the cosmos come to it, one gentle particle at a time. Stars may orbit it for 10 billion years without ever falling in. Entire generations of galaxies swirl around these dark hearts, thriving, blooming with new suns and new worlds, while the black hole within grows by only the smallest whisper of a percent. And far, far in the future, longer than we can easily imagine, physicists tell us that black holes will do something remarkable. They will slowly evaporate, Through a faint quantum whisper called Hawking radiation, they will give back, bit by tiny bit, the mass they spent eons gathering. A black hole the mass of our sun would take a trillion, and many more trillions of years to fade away. The slowest story the universe has ever told at the slowest possible pace. So tonight, as you settle into rest, you might carry this image with you of patient darkness at the heart of the galaxies, growing not with haste, but with stillness, keeping cosmic time on a clock that ticks once every million years. The universe is in no hurry, nothing truly important is rushed. Let your breath slow to match that ancient rhythm. The stars will keep shining, the galaxies will keep turning, and the black holes will keep waiting gently through eon after eon, while you drift softly into sleep. Hello and welcome. Settle in now wherever you are, let your shoulders soften and let your breath slow down. Tonight, we're going to travel together very gently to one of the most quietly astonishing places in our galaxy, a planet made of diamond, glowing softly in the deep dark of the Milky Way. Before we arrive, let's take our time getting there. Imagine the night sky above you. Every single point of light you see is a sun, and behind them, beyond them, stretches the great river of stars we call the Milky Way. Our galaxy holds hundreds of billions of stars, and drifting around many of those stars are worlds. Some burning, some frozen, and some, like our destination tonight, made of things we once thought only existed in fairy tales. Our journey takes us thousands of light years, but there's no rush. We drift the way a leaf drifts on a calm stream, past soft clouds of nebulae, glowing in gentle blues and purples like watercolor painted across black velvet. The stars slide by slowly, one by one, like lanterns hung in an endless garden. And then we arrive. The planet's name, if you'd like to know it, is often called 55 Cancri E, though astronomers have affectionately nicknamed it the Diamond Planet. It orbits a star in the constellation Cancer, a star you could see from Earth on a truly dark night if you knew just where to look. What makes this world so special? Well, scientists believe that beneath its warm, amber-colored surface, a great deal of this planet may be composed of carbon, and under the immense pressure of all that weight pressing down from above, carbon does something wonderful. It crystallizes. It becomes diamond. Imagine that for a moment, a world where the ground itself, deep below the surface, sparkles, vast layers of crystalline carbon stretching further than any ocean on Earth. If you could see beneath its crust, you would find a shimmering interior, like the inside of a geode the size of a world, catching and folding light in quiet, glittering ways. Now the surface itself is warm, quite warm actually, because this planet sits very close to its star, completing a full year in just a few of our days. Its skies glow a gentle amber, and its rocky plains are bathed in a soft, eternal twilight from its nearby sun. But don't worry, we're only visitors tonight. We float safely above it all, watching, admiring, letting the sight wash over us. How did such a planet come to be? It's a slow, patient story, billions of years long. When its star was young, a great disk of dust and gas swirled around it, and from that dust, this planet formed, gathering itself together grain by grain, the way a snowball grows in careful hands. Its star, it turns out, is rich in carbon, more so than our own sun. And so the little world that formed there inherited that character. It became a carbon world. And carbon, given time and pressure, becomes something precious. There's something lovely in that thought, isn't there? That out there in the dark, ordinary dust, the same kind of stardust that makes up you and me, can slowly, quietly transform into something radiant, not through hurry, not through force, but simply through patience, through time and gentle pressure, doing its quiet work. As we hover here, our diamond planet turns slowly beneath us. Its star rises over its amber horizon, warm and steady. Far in the distance, its sister planets trace their calm circles, silent and graceful. And beyond them all, the great star field of the Milky Way stretches out in every direction. Thousands of soft points of light, each one a promise of more stories, more worlds, more quiet wonders waiting to be discovered. Scientists found this planet by watching its star, noticing the tiniest, gentlest wobble and the faintest dimming as the planet passed in front, like a moth drifting across a distant candle. Isn't that beautiful, that such a remarkable world was discovered not with loud fanfare, but with patience, with careful, quiet attention to small, subtle things? Perhaps there's a lesson there for us tonight too. The most extraordinary treasures are often found by those who move slowly, who pay attention, who are willing to sit quietly and watch, just as you are doing now. So rest your eyes if you'd like. Picture that diamond world glowing softly in the deep dark, its crystal heart hidden beneath amber skies, turning gently through the endless, peaceful night. It has been there for billions of years, and it will be there long after, serene and sparkling, a small jewel in the vast velvet of the Milky Way. And you can drift now too. Let the stars carry you. Let your breathing grow slow and deep, like the slow orbit of distant worlds. The galaxy is calm tonight. The diamond planet shines quietly in the dark, and everything, everywhere, is at rest. Sleep well and dream of sparkling worlds. Tonight, we drift quietly away from our own familiar skies, out past the moon, past Mars, past the gentle belt of ancient stones, to visit a strange and beautiful family of worlds that astronomers call hot Jupiters. Imagine Jupiter, our solar system's largest planet, a giant made of swirling clouds and deep, endless atmosphere. Now imagine that giant moved very close to its star, so close that a full year there lasts only a few days, sometimes only a few hours. These are hot Jupiters, enormous gas giants huddled near the warmth of their suns, glowing softly in the light of their parent stars. For a long time, we knew of only one arrangement of planets, our own, small rocky worlds near the sun, and the great gas giants far away in the cold outer dark, where sunlight is faint and gentle. That made sense to us. It seemed natural, orderly, like well-behaved children sitting quietly in their assigned seats. But in the year 1995, two Swiss astronomers, Michel Mayer and Didier Queloz, were studying a star called 51 Pegasi, a quiet sun not so very far from our own. As they watched, they noticed something curious. The star seemed to wobble gently back and forth in a slow, patient rhythm, like a dancer swaying with an unseen partner. That wobble, they realized, was caused by a planet, and not just any planet, a giant one, at least half the mass of Jupiter, circling its star every 4 days. 4 days, our Earth takes 365 days to make its slow journey around the sun. This giant world completed its whole year before a single week had passed. Astronomers were astonished and quietly delighted. The universe, it seemed, had far more imagination than we did. So how does such a world live so close to its star? Picture it now softly, a great gas giant hovering in the fierce nearness of its sun. The star does not rise and set as our sun does for us. Instead, the planet turns one face forever toward the light, the other forever toward the dark. On the day side, temperatures climb higher than any summer Earth has ever known, thousands of degrees, hot enough to glow faintly like a coal in a dying fire. On the night side, cooler air drifts. And somewhere between the two, winds push and pull, sometimes howling at thousands of kilometers per hour. Though from far away, watching through a telescope, it all looks perfectly still. A distant dot of light, calm and unhurried. These worlds have strange and lovely weather. Some have clouds made not of water, but of vaporized rock or tiny particles of glass that catch the starlight and scatter it softly. Some hot Jupiters glow in shades of deep blue. One, we have learned, may rain molten glass sideways through its skies, and their atmospheres stretch and swell in the heat, puffing outward like warm bread rising, making some of them the puffiest planets we have ever found. You might wonder, how did they get there in the first place? Surely such a giant could not have formed so close to its star, where there is little material and so much heat. Most astronomers believe these worlds formed farther out, in the cool, quiet outskirts of their systems, where ice and gas drift gently together and giants can grow in peace. And then, slowly, over millions of years, they wandered inward. They drifted toward their suns, drawn by the pull of gravity and the friction of the great disks of gas that surrounded their young stars. Some settled into the tight, close orbits we see today, and there they remain, steady and content, circling and circling in their short, quick years. Since that first discovery in 1995, we have found hundreds of hot Jupiters, each one a little different, each one with its own personality. There is one that orbits so close to its star that its year lasts barely a day and a half. There is another so dark it absorbs almost all the light that touches it, a shadow world, quietly orbiting like a tiny eclipse. Some have rings, some have moons we have not yet seen but quietly suspect. And every one of them reminds us of something gentle and true, that the universe loves variety, that planets are not all copies of our own, that somewhere out there, giant worlds are drifting through the warmth of their suns, wrapped in glowing clouds, completing their years while ours has barely begun. For astronomers, hot Jupiters are wonderful teachers because they are big and close to their stars. They are among the easiest planets to find and study. They taught us how to listen for the wobble of distant suns, how to watch for the tiny dip of light when a planet passes in front of its star, like a moth drifting across a lantern. They opened the door to all the worlds we would find afterward. The rocky ones, the ocean ones, the quiet Earth-sized ones that may hold more familiar comforts. So tonight, as your eyes grow heavy, let a hot Jupiter drift through your thoughts. A great glowing giant, wrapped in golden clouds, circling its sun every few days. Patient, serene, far beyond all our worries. The universe is vast and calm and full of wonders. Rest now and drift as gently as a giant world, circling softly in the light of its own quiet star. Close your eyes for a moment and let your mind drift upward, past the clouds, past the quiet edge of our sky, out into the deep, patient dark of space. Tonight, we are going to visit a very special kind of world, planets wrapped entirely in water. Endless, gentle oceans with no shores at all, worlds that astronomers like to call water worlds. Imagine, if you will, standing on a small boat, only there is no boat and there is no land. In every direction, as far as you could ever see, there is only soft, rolling water, reflecting the light of a distant star. Above you, the stars shine quietly through a thin veil of atmosphere, and below you, the ocean stretches downward, further than sunlight has ever reached. This is what it might feel like on a water world, a planet that is not a world with an ocean, but simply an ocean all the way through. For a long time, scientists believed that planets came in only a few familiar shapes, rocky worlds like our Earth and Mars, and great gas giants like Jupiter and Saturn. But as telescopes grew more sensitive, and as astronomers began discovering thousands of planets orbiting faraway stars, they started finding something curious: planets larger than Earth, but smaller than Neptune, worlds that seemed too big, too light, too fluffy to be made of solid rock alone. What could fill all that space? The answer, as it turns out, may be water, deep, deep layers of it. You see, when planets form around young stars, they gather material from the cold outer regions of their systems, where ice is plentiful. Some of these planets drift slowly inward over millions of years, carrying their frozen cargo with them. As they settle into warmer orbits, the ice melts and melts and melts, until entire planets become wrapped in global oceans, some hundreds of kilometers deep, some perhaps even deeper than that. Think about that for a moment. An ocean on Earth, even at its deepest point, the Mariana Trench, reaches down about 11 kilometers. Impressive to us, but only a thin skin on our planet. Now imagine an ocean hundreds of times deeper than that, an ocean so vast that the very bottom of it behaves differently, where the water itself, pressed by unimaginable weight, compresses into strange, exotic forms of ice. Ice that is hot, ice that exists only because of pressure. Not cold, scientists call these high-pressure ices, phases like Ice 7, Ice 10, beautiful, crystalline structures that could never exist here at the surface. And yet, even on these alien seas, there is a strange sense of calm, because water has a wonderful quality. It holds heat gently. It moves slowly when it is deep. It cushions everything. If a water world orbits a calm, steady star, Its ocean may be remarkably peaceful, warm mists rising in the morning, soft rains falling in the evening, waves that roll in long, slow rhythms, unhurried by any shoreline to break against. Astronomers have already found promising candidates, planets like K218b far away in the constellation of Leo, and worlds like TOI 1452b discovered not so long ago, planets whose sizes and densities suggest they could be covered in deep water. We cannot yet see their oceans directly, but scientists study their light, the faint starlight that filters through their atmospheres, looking for the telltale whispers of water vapor, and perhaps someday, signs of something even more wonderful. Because here is a gentle thought to carry with you into sleep. Some scientists believe that in the darkest, deepest layers of these oceans, near warm hydrothermal vents, where heat seeps up from the planet's interior, the ingredients for life might gather, just as life may have first stirred in Earth's own deep seas, protected from radiation, sheltered, cradled in darkness and warmth. So too might quiet, simple life exist on a water world. Drifting, growing, entirely unaware of the stars above. So if you ever feel small, remember that the universe is filled with hidden oceans, whole planets made of water, softly glowing under distant suns, waiting patiently to be known. And now, as you settle deeper into your blankets, imagine yourself drifting on one of those calm seas, the sky above you scattered with unfamiliar constellations, two small moons rising slowly on the horizon, the water warm and still, rocking you gently, side to side, side to side. There is no rush here, no noise, no need to do anything at all, only the slow breathing of an alien ocean, carrying you softly, softly towards sleep. Good night, traveler, rest now, among the water worlds of the stars. Tonight, let us drift together to a quiet corner of our galaxy, about 40 light years from home, a place where 7 small worlds circle a single, gentle star. Imagine, if you will, a star far smaller than our own sun. Astronomers call it TRAPPIST-1, a tiny, cool, reddish star barely larger than the planet Jupiter. It burns slowly and softly, like an ember in a hearth that will glow warmly for trillions of years, far, far longer than our sun ever will. And around this little star, like delicate beads on an invisible thread, 7 planets make their patient journeys. Each one is close in size to our own Earth. 7 small, rocky worlds, siblings born together from the same soft cloud of dust and gas, some 12 billion kilometers wide, yet all of them could nestle comfortably inside the orbit of Mercury around our sun. Story of their discovery is a gentle one. In a cool mountain observatory in Chile, a small robotic telescope named TRAPPIST, the Transiting Planets and Planetesimals Small Telescope, quietly watched the sky night after night. It was not a giant instrument. It was modest and patient, and in its careful watching it noticed something subtle, a tiny dimming of that little red star, again and again, as if something were passing in front of it, like a moth drifting across a candle flame. That dimming was the shadow of a planet. Then NASA's Spitzer Space Telescope, peering from its silent orbit, watched for over 1,000 hours, and found not one world, not 3, but 7 planets, whispering their presence through the faintest flickers of starlight. Because these planets orbit so close to their small, cool star, their years are wonderfully brief. The innermost world completes a full journey in just a day and a half. The outermost takes less than 20 days. If you lived there, you could watch years pass like gentle waves, one after another. From the surface of one of these worlds, the star would hang enormous in the sky. A vast, deep red sun, 3 times larger than our sun, appears from Earth. Its light would be soft and amber, like the glow of sunset that never quite ends. Imagine standing there, feeling that warm reddish light on your face, watching it shift and shimmer. Some of these 7 planets sit in what scientists call the habitable zone, that comfortable band of distance where a world is neither too hot nor too cold. It is the region where water, if it is there, could remain liquid, pooling in quiet seas, resting in hidden lakes, perhaps flowing in slow rivers beneath soft skies. We do not yet know what these worlds truly look like. Telescopes like the James Webb Space Telescope are now studying their atmospheres, reading the faint starlight that filters through the air around each planet, searching for gentle clues, traces of carbon dioxide, perhaps, or methane, or something even more intriguing. Perhaps some of these worlds are wrapped in thick, hazy atmospheres. Perhaps others are bare and quiet, like our moon. Perhaps tidal forces, the same gentle tugging that raises our ocean tides, have locked them so that one side always faces their star, keeping one face in eternal twilight while the other rests in permanent, peaceful night. Along the border between light and dark, there may be a soft ribbon of land where the temperature is just right. A permanent, gentle sunset zone stretching around the whole world. What a beautiful thought, a place where dusk is not a moment, but a home. These 7 planets are also remarkably close to one another. From the surface of one, you might see its sister worlds in the sky, sometimes larger than our moon appears to us, drifting slowly, phase by phase, like quiet companions. On rare occasions, several of them would line up, one after another, tiny shadows crossing the face of the great red sun. The TRAPPIST system reminds us of something calming and true. Our galaxy holds hundreds of billions of stars, and around many of them, planets gather like family. Small, rocky worlds may be everywhere, quiet places, waiting patiently through deep time. We are only beginning to learn how to see them. And here, in this little red star's domain, 7 of them circle together, enduring, patient, and serene. Their star will keep shining long after our sun has faded, a warm ember warming its small family for ages beyond imagining. So as you close your eyes tonight, picture it, a small red star in the deep black quiet of space, and 7 gentle worlds turning slowly around it, one after another, each in its own perfect rhythm. A silent, steady dance that has continued for billions of years and will continue long, long after tonight. Rest now and let the 7 worlds of TRAPPIST one turn softly in your dreams. Welcome, gentle traveler. Settle in, get comfortable, and let your breathing slow as we drift away from our familiar world to explore something quietly wonderful, the seasons of distant planets. On Earth, we know the seasons well. Spring brings soft rain and blossoms. Summer warms the long afternoons. Autumn paints the leaves in amber and gold, and winter tucks the world beneath a quiet blanket of snow. These changes happen because our planet leans, tilted ever so slightly, about 23 degrees, as it journeys around the sun. That gentle tilt is why half the year feels like a slow inhale of warmth and the other half like a long, soft exhale of coolness. But out among the stars, seasons can be very different indeed. Consider a world called Kepler 16b, a planet that orbits not one sun, but 2. Imagine standing on its surface at dusk, watching 2 suns sink together toward the horizon, casting double shadows in the fading light. Its seasons would be shaped by an intricate dance, a waltz between 2 stars, each pulling at the planet with its own gentle gravity. Some years might feel warmer, others cooler, following rhythms no calendar on Earth could predict. Then there are the hot Jupiters, enormous gas giants that huddle close to their stars, completing an entire year in just a few Earth days. Their seasons are less like our slow turning of the year, and more like a fleeting breath, a spring that lasts only hours, a summer gone before it truly settles. And unlike Earth, these worlds are often tidally locked, one face forever turned toward their star, basking in endless daylight, while the other face gazes eternally into the dark stillness of space. No tilt. No traditional seasons at all, just 2 permanent worlds folded into one. Some planets tilt far more than ours. A world called Uranus, within our own solar system, rolls along on its side, tilted almost 98 degrees. If Earth tilted that way, the seasons would stretch dramatically, decades of continuous sunlight at the poles, followed by decades of gentle twilight and night. Imagine a winter that lasts an entire generation. A long, patient dusk where stars wheel slowly overhead, and then, at last, a sunrise that arrives like a promise kept. Exoplanets may hold similar wonders, Astronomers have found worlds with highly elliptical orbits, paths that carry them close to their star, then far away again. For such a planet, the distance from its sun changes dramatically through the year. When it swings close, the whole world warms. Oceans, if it has any, might stir with summer storms. As it drifts out to the cold reaches of its orbit, a planetary winter settles in, perhaps freezing its atmosphere in places, letting frost shimmer across its surface, until the slow return brings warmth again. One season of fire and one of frost, each lasting months, dictated not by tilt, but by the shape of the journey itself. And still stranger are the wandering worlds, planets that orbit no star at all, drifting through the galaxy in eternal night. If seasons exist there, they are measured not in sunlight, but in the slow decay of their own inner warmth, the faint glow rising from their cores, a kind of season made only of memory and residual heat, soft and dim as an ember in the dark. What ties all of these worlds together, what makes their seasons so different from ours, comes down to three quiet things: the tilt of a planet's axis, the shape of its orbit, and the presence of one sun, or two, or none at all. Change any of these gentle variables, and the rhythm of the year transforms entirely. Our own seasons feel so constant, so reliable, because Earth found a soft middle path, a modest tilt, a nearly circular orbit, a single steady sun. In the great variety of worlds, we may be the calm ones, the lucky ones wrapped in an even, gentle rhythm. So as you drift towards sleep tonight, perhaps imagine yourself on some distant shore under a sky with two setting suns. Or watching a decades-long twilight finally give way to dawn. These faraway seasons unfold slowly, patiently, across light years of silence, utterly indifferent and utterly peaceful. And here on our small blue world, spring will come again, the way it always has. The light will lengthen, the air will soften, and the stars above will keep their quiet watch over worlds we may never see, each one turning gently through its own long year. Rest now. And let the seasons of 1,000 distant planets carry you softly into your dreams. Hello there and welcome, and settle in, get comfortable, and let your body grow heavy and warm. Tonight, we're going to take a slow, gentle journey through the scale of the universe, not to feel small in a frightening way, but to feel small in a peaceful way, the way you might feel lying on soft grass, watching the stars drift quietly above. Let's begin with something familiar. You resting here, about a meter of warmth and breath. Just below your feet is the Earth, and the Earth feels enormous to us, and it is, in its own gentle way. If you walked around its equator day after day, it would take you years. And yet, from the moon's perspective, Earth is a small blue marble, hanging in the dark like a dewdrop on a leaf. The moon itself is about 380,000 kilometers away. That sounds far, but it's the closest neighbor we have. Light, the fastest thing there is, takes just over 1 second to make that trip. When you gaze at the moon tonight, you're seeing it as it was a heartbeat ago. Nothing more dramatic than that, just a soft little delay, like an echo across a quiet lake. Now we drift outward. The sun, our warm companion, sits about 150 million kilometers away. Its light takes a little over 8 minutes to reach us. So when you feel sunshine on your face in the morning, you're feeling light that left home 8 minutes earlier, traveling patiently across the emptiness just to warm your skin. Past the sun, we find the other planets, each in its own slow orbit. Mars is a few light minutes away. Jupiter, the great soft giant, is about 35 light minutes out. Saturn, with its calm and elegant rings, is over an hour away by light. Imagine that, a single beam of light, racing as fast as anything can race, needing more than an hour to glide from Saturn to your window. And here the numbers begin to grow so large that astronomers needed a gentler unit of measure, so they began speaking in light years. The distance light travels in a whole year, nearly 10 trillion kilometers, a unit not of time, but of quiet, immense distance. Our nearest stellar neighbor, Proxima Centauri, is about 4 light-years away. If you looked at it tonight, you'd be seeing light that set out 4 years ago, light older than many of the memories you hold dear. Keep drifting outward, and you find the full sweep of our galaxy, the Milky Way. It is a vast, slowly turning spiral of stars, dust, and soft glowing gas, home to hundreds of billions of suns. From one side to the other, it stretches about 100,000 light-years. Our own star sits in a quiet suburb of that spiral, about halfway out, circling the galactic center every couple 100 million years in an unhurried cosmic waltz. The nearest large galaxy to our own is Andromeda, a soft, faint smudge you can sometimes see on very dark, clear nights. It lies about 2.5 million light-years away. The light reaching your eyes from Andromeda began its journey before humans ever walked the Earth. And yet there it is, patient, visible, gently arriving. Beyond Andromeda lie billions upon billions of other galaxies, gathered loosely into clusters, and the clusters into great filaments that span the observable universe, about 93 billion light-years across. Numbers like that are beyond imagining, and that's all right. We don't need to hold them in our minds. We can simply let them wash over us, like the sound of distant waves. Here is the peaceful secret of all this vastness. The universe is not empty. It is threaded with light, with slow-forming clouds of gas that will one day become stars, with planets drifting around countless suns, perhaps with quiet oceans on distant worlds. Everything out there follows the same gentle physics that lets you breathe, that lets rain fall, that lets flowers turn toward the sun. You are not separate from the cosmos, you are made of it. Of atoms forged long ago in the hearts of ancient stars, scattered across space, gathered here, into you, resting softly tonight. So as your eyes grow heavy, remember this: you live on a beautiful small world, tucked into a quiet arm of a magnificent galaxy, drifting through a universe of unimaginable size. And yet somehow it all fits together perfectly. The distances are vast, but they are not cold. They are simply room for light to travel, room for stars to form, room for you to be here, safe and warm, exactly where you are. Let the scale of it all carry you now further and further, outward and inward at once, into rest, into stillness, into sleep. Good night and pleasant dreams among the stars. Welcome back, dear friend. Settle in, let your shoulders soften, and let your breath slow down. Tonight, we're going to drift through the solar system together and explore something wonderfully gentle: how long it takes light to travel from each planet to our eyes here on Earth. Light is the fastest thing we know of. It rushes through empty space at nearly 300,000 kilometers every second, a speed so great that a beam of light could circle our entire planet 7 times in a single second. And yet, even at this incredible pace, space is so vast, so beautifully, quietly vast, that light still takes time to reach us. When you look up at the night sky, you are never seeing the present moment. You are seeing gentle messages sent long ago, arriving now, like letters that traveled across the sea of space. Let's begin close to home, with the moon. Its light takes just over 1 second to reach us. So when moonlight rests on your face tonight, you are touching light that left the moon while you were still drawing a single slow breath. Now we drift inward toward the sun. Its light takes about 8 minutes and 20 seconds to arrive. Every golden sunset you've ever watched, you saw the sun as it was 8 minutes before. The sun could, in some quiet hypothetical moment, dim, and we would still bask in its warm glow for 8 more peaceful minutes, completely unaware. Next, let's visit Mercury, the small, swift world closest to the sun. On average, its light takes somewhere between 4.5 and 11 minutes to reach us, depending on where the planets are in their orbits. Sometimes Mercury passes near us on the same side of the sun, sometimes it circles far away on the opposite side. Distance, in space, is a soft, changing thing. Venus, our lovely bright evening star, sends its light in about 3 to 14 minutes. When Venus hangs low in the twilight sky, glowing steadily like a lantern, remember, that gentle glow began its journey to you while you were perhaps finishing dinner or pouring a warm cup of tea. Mars, the rusty red world, takes anywhere from about 3 minutes to 22 minutes for its light to arrive. When we send little robotic rovers to explore Mars, engineers must wait patiently for messages. a conversation where each reply takes many minutes to travel the quiet distance between worlds. Now we move outward, past a great belt of ancient rocky fragments, to Jupiter, the giant of the solar system. Its light takes roughly 35 to 52 minutes to reach Earth. So Jupiter in your evening sky is a view from the better part of an hour ago. Imagine that, a planet wrapped in soft, swirling clouds, sending its image across half a morning's time just to say hello. Saturn, with its magnificent rings of ice and dust, takes about 1 hour to 1 hour and 20 minutes for its light to arrive. When Saturn rises quietly over the horizon, you are seeing it as it was while a whole film played, while soup simmered, while someone drifted off to sleep. Uranus, the pale, tilted world, takes between roughly 2.5 and nearly 3 hours. Its gentle blue-green light left home while an afternoon was still unfolding and arrived in time for your bedtime. And Neptune, far out in the deep blue quiet, takes about 4 hours, sometimes a little more, sometimes a little less. When Neptune's faint light touches your eyes, 4 hours have passed, whole evenings, whole journeys, all folded into a single, delicate point of light. There is something profoundly calming in all of this. The universe is patient. It does not hurry. Light travels faithfully, steadily, second after second, minute after minute, across distances that would take human lifetimes to cross. And yet it arrives every night without effort or fuss. It simply comes and touches us softly. So the next time you step outside and look up, you can think of the sky as a gentle archive. The moon 1 second old, the sun 8 minutes old, Saturn an hour old, Neptune 4 hours old, each point of light a small, peaceful postcard, written long ago, delivered tonight, just for you. The planets do not rush. The light does not worry. Everything moves at its own perfect pace through the great dark, and everything arrives exactly when it is meant to. Let that thought carry you now, gently, like light crossing the quiet between worlds, slowly, softly, toward rest. Good night, dear friend, sleep well, and drift as peacefully as starlight on its long, unhurried way. Tonight, we drift gently away from everything familiar, following two small travelers that left home long before many of us were born. Their names are Voyager 1 and Voyager 2, and they are still whispering to us from the very edge of the solar system. It began in the summer of 1977, a warm and hopeful time on Earth. From a quiet launch pad in Florida, a slender rocket lifted two spacecraft into the night sky. They were small, each about the size of an old-fashioned car, carrying golden instruments, long antennas, and something truly precious, a golden record. That golden record holds greetings in many languages, the sound of a heartbeat, laughter, birdsong, the gentle crash of ocean waves. It was placed aboard as a message in a bottle, not really expecting anyone to find it, but hoping, quietly, that somewhere, someday, someone might. The Voyagers journeyed outward on grand tour of the giant planets. Voyager 1 visited Jupiter first, and what it saw was beautiful beyond expectation. Swirling clouds of amber and cream, a great red storm larger than our entire world, and around Jupiter, moons of ice and fire. One of those moons, Io, was dotted with active volcanoes, a surprise that made scientists back home smile in wonder. Then came Saturn, its rings stretching out like delicate circles of frost and light. Voyager 1 drifted past in 1980, taking photographs so clear they looked like paintings, rings made of countless tiny ice fragments, each one following its own quiet path around a golden planet. Voyager 2 took the longer, more patient road, visiting Uranus, a pale blue-green world tipped gently on its side, and then Neptune, deep blue and serene, with winds that sang across its atmosphere faster than any on Earth. After Neptune, Voyager 2 turned quietly southward, and both spacecraft began their longest journey of all, outward into the dark. And what a darkness it is, past the planets, past the icy belt of small worlds. The sunlight grows faint and soft, like a candle seen from a distant hillside. Here, the space between things becomes wider and quieter, and yet it is not empty. For the voyagers carry instruments that listen. They feel the solar wind, the gentle breath of particles that flows outward from our sun like a warm breeze. And far out here, that breeze finally slows and softens and gives way to something else. The thin, cold drift of particles from the space between stars. In 2012, Voyager 1 crossed this invisible shoreline, a boundary scientists call the heliopause. It was the moment a human-made object first entered interstellar space, the vast ocean between the stars. Voyager 2 followed a few years later, crossing on its own quiet path. Neither spacecraft announced the moment with any fanfare. They simply kept drifting, kept listening, kept whispering their small findings back home. Those whispers take a long time to reach us. A signal from Voyager 1 travels at the speed of light and still takes more than a day to arrive. When it finally reaches our antennas, deep dish ears in California, Spain, and Australia, it is astonishingly faint, billions of times weaker than the signal from a phone, yet there it is, steady and faithful, a voice from very far away. And the whispers tell us beautiful things, that the space between stars is not silent. It hums with gentle plasma waves, like a soft, persistent note, that the boundary of our sun's embrace is not a wall but a gradual easing, one kind of quiet flowing into another, that even far from home in the deepest cold, a well-made machine, loved and tended by patient engineers, can keep going. The people who care for these spacecraft are wonderful to think about. A small team who check in each day, send gentle instructions, celebrate each birthday, 40, 45, 50 years, like tending a lantern that never quite goes out. One day, perhaps in the 2030s, the power will grow too faint, and the whispers will stop. The voyagers will fall silent, but they will not stop traveling. They will drift onward through the galaxy for billions of years, each still carrying its golden record, Bach and Beethoven, a mother's greeting, the sound of rain. Long after our sun has changed, long after everything we know has shifted, these two small messengers will still be gliding through the star fields, carrying a little piece of Earth's evening, its music, its kindness, its curiosity. So tonight, as you rest, imagine them out there, two quiet travelers moving slowly through the dark between stars, still whispering, still listened for, still, in their own gentle way, connecting us to something vast and beautiful. Let that thought carry you softly now, outward and peaceful, into sleep. Hello and welcome. Find a comfortable position, let your shoulders soften, and let your breath slow to an easy rhythm. Tonight, we're going to drift together through a small, quiet story about a very small picture, and the surprisingly gentle lessons it holds. In the year 1990, a small spacecraft called Voyager 1 was very, very far from home. It had already visited Jupiter and Saturn. It had spent more than a decade traveling through the darkness. And now, it was drifting beyond the outer planets, heading toward the deep quiet at the edge of our solar system. Before it turned its face forever outward, a scientist named Carl Sagan made a soft suggestion. He asked the spacecraft to do one last thing, to turn around and look back. And so, from almost 4 billion miles away, Voyager 1 took a photograph. In that photograph, the Earth appears as a single, tiny point of light, a pale blue dot, barely more than a single pixel, suspended in a beam of scattered sunlight, small enough to be missed entirely if you didn't know where to look. Think about that for a moment. Everything you have ever known, every person who ever lived, every ocean, forest, city, and quiet bedroom like the one you may be resting in right now, all of it exists on that one small fleck of blue. There is something deeply calming about this if we let it settle over us, like a soft blanket of perspective. The first thing the pale blue dot quietly teaches us is humility, but not the heavy kind. It is a gentle humility, the kind that loosens the knots we tie in ourselves during the day. That argument that felt so large, the worry that followed you to bed, from 4 billion miles away, they soften into stillness, not because they don't matter, but because they are held inside something so much larger, so much older, and so much more patient than we are. The second lesson is about our shared smallness. From that distance, there are no countries, no borders drawn in the dust. There are no strangers in that photograph, only one world, one blue breath of light carrying everyone together. When you feel alone tonight, remember, you are never truly separate. You are resting on the same small sphere as every person who has ever watched the stars, ever hummed a lullaby, ever closed their eyes at nightfall and let sleep carry them gently away. And the third lesson, perhaps the most tender of all, is gratitude. That dot is blue because of water, because of air, because of a thin, delicate atmosphere that has cradled life for billions of years. Out of all the vast blackness of space, all the silent worlds of rock and ice, this little blue point learned to bloom. Grass grew, whales sang, fireflies blinked in summer evenings, and somewhere along the way, human beings learned to wonder, to look up, and to love. Voyager 1 is still traveling, even now. It moves through the darkness at about 10 miles every second, carrying a golden record filled with the sounds of Earth, greetings in many languages, laughter, a heartbeat, music. It is, in a way, a message in a bottle, floating on an ocean far larger than any ocean we have ever sailed. It may drift for billions of years, long after our sun has changed, a quiet ambassador from the pale blue dot. And that's all right. Space is patient. It does not hurry, and it does not demand. The stars burn steadily. The galaxies turn slowly, and everything in the universe moves at the speed of calm. So as you settle in tonight, picture it if you like, a small spacecraft far, far away, turning gently and taking one last photograph of home. A single blue speck of light, glowing softly in a sunbeam, holding all of us, everyone you love, everyone you will ever meet, everyone who has ever been. Let that image rest in your mind like a pebble in a still pond, small, warm, and shining. You are made of star stuff, as the old saying goes. The iron in your blood and the calcium in your bones were forged in ancient, distant suns. You are the universe, briefly arranged into a person who can feel the softness of a blanket and hear the quiet of the night and drift towards sleep. There is no rush here. The pale blue dot has been spinning peacefully for 4.5 billion years, and it will keep turning gently all through the night. So breathe slowly, let your eyelids grow heavy, and let the small blue world carry you as it has always carried everything, softly onward. Good night and sleep well. Tonight, let us drift gently into one of the quietest and most wonderful ideas in all of science. The idea that the universe is expanding, a little like a loaf of bread rising slowly in a warm kitchen. Imagine, if you will, a baker working late into a peaceful evening. She prepares her dough, folds in a handful of tiny raisins, and sets it aside to rise. Slowly, patiently, the dough swells. And here is the gentle magic of it. Every single raisin moves away from every other raisin, not because any raisin is special, not because they are racing towards some edge, but simply because the dough itself, the space between them, is stretching. The raisins, dear listener, are the galaxies, and the dough is space itself. When astronomers look out into the night sky with their great patient telescopes, they find something remarkable. Nearly every galaxy they observe is drifting away from us, and the farther away a galaxy is, the faster it appears to recede. At first, this might sound lonely, but it is not. It is simply the bread rising. From any raisin, from any galaxy at all, every other raisin seems to be moving away. Whichever one you call home, the view would be much the same. There is no center to rush toward, no edge to fear, just soft, even expansion everywhere at once. This discovery came quietly, almost a century ago. An astronomer named Edwin Hubble, working under the calm desert skies of California, noticed that the light from distant galaxies had been stretched. Their colors had shifted, ever so slightly, toward the red end of the spectrum, a gentle change we now call redshift. It is much like the sound of a passing train, lowering in pitch as it moves away. Light, too, grows longer and softer as its source drifts from us. And why does this stretching happen? Because space itself is growing. Not the galaxies drifting through space like boats on an ocean, but the ocean between the boats widening. It is a strange and beautiful thought. The galaxies are, for the most part, quite still. It is the very fabric between them, the emptiness, that quietly expands, carrying them apart like currents in rising dough. In the earliest moments, nearly 14 billion years ago, everything was unimaginably close together, warm, dense, and bright. Then, over countless ages, the universe cooled and stretched, and its energies softened into the stars and galaxies we know today. That ancient warmth has not vanished entirely. It still lingers faintly as a whisper of microwave light filling all of space. A gentle afterglow, like the last warmth of an oven long after the baking is done. You might wonder, if everything is expanding, are we expanding too? Are our beds, our blankets, our own bodies stretching along with the universe? Happily no. On small scales, gravity and the other forces hold everything snugly together. The Earth holds you. The Sun holds the Earth. Galaxies hold their stars close. The expansion only becomes noticeable across the vast, empty distances between galaxies, where gravity's soft grip grows faint and space may stretch undisturbed. There is something deeply calming in this picture if you let it settle over you. The universe is not rushing anywhere. There is no deadline, no destination. It simply unfolds, unhurried, on timescales so long that human lives are like the blink of a firefly. In the entire history of human civilization, the galaxies have drifted apart by only the tiniest fraction. The bread rises slowly, so slowly that the night sky above us remains a picture of stillness and permanence. And yet the change is there, patient and constant, written in the red-shifted light of a million distant suns. Scientists sometimes describe the expansion with a number they call the Hubble constant, a measure of just how gently space stretches, a soft, steady breath drawn by the cosmos. So as you close your eyes tonight, you might imagine yourself as one small raisin in an enormous, tender loaf, resting among countless others, all drifting slowly apart across a soft and darkening expanse. Nothing to chase, nothing to fear, just the quiet, endless rising of everything, carrying the galaxies, and you, safe and still, gently onward. Rest now under the slow, kind expansion of the universe, and let it carry you, like warm dough in the dark, into sleep. Tonight, as you settle into the quiet of your room, let us drift together into the gentle darkness between the stars, a darkness that holds one of the universe's most beautiful secrets. Look up in your mind's eye at the night sky. You see stars scattered like soft embers, galaxies swirling like cream stirred slowly into coffee. For centuries, we believed that what we could see was all there was. But the universe, it turns out, is far more mysterious than that. Hidden within that velvet blackness is something we cannot see, cannot touch, and cannot yet hold in our hands, something scientists call dark matter. Imagine for a moment that you are watching a garden in the wind. You cannot see the wind itself, but you can see the leaves trembling, the branches swaying, the petals dancing. In the very same way, astronomers cannot see dark matter directly. Instead, they watch the way it moves the things around it, bending light, guiding stars, holding galaxies together like an unseen, tender hand. The story of this discovery begins quietly in the 1930s with an astronomer named Fritz Zwicky. He was studying a distant cluster of galaxies and noticed something puzzling. The galaxies were moving too quickly, so quickly, in fact, that they should have drifted apart and scattered into space long ago. Something invisible had to be holding them together, something with gravity but with no light. He called it Dunkel Materie, dark matter. It was a quiet observation, easily forgotten, but the universe was patient. Decades later, in the 1970s, an astronomer named Vera Rubin studied the way stars orbit within galaxies, and she found something remarkable. At the edges of galaxies, far from the bright, crowded centers, the stars were moving far too fast. According to everything we understood about gravity, those outer stars should have wandered off slowly, like children drifting away from a campfire. But they didn't. They stayed close, held firmly in place. Something enormous and unseen was wrapping around every galaxy. A vast, invisible halo, gently cradling its stars like hands cupped around a small flame. And so the picture began to form. Every galaxy you have ever seen in a photograph, every swirling spiral of light, is only a small, glowing heart wrapped inside something much, much larger. The visible part of a galaxy is like the foam on top of a wave, beautiful, bright, and only a fraction of the whole. Beneath it stretches an immense halo of dark matter, perhaps 10 times heavier than all the stars and gas and dust combined. What is this strange substance? Scientists have searched for decades. It is not made of atoms like you and me. It does not shine, does not reflect light, does not absorb it. It passes through ordinary matter almost without a whisper. Countless invisible particles may be drifting through this very room and through you as you listen, leaving no trace at all. Deep underground, in mines and mountains, physicists wait patiently behind shields of lead and ice, hoping one day a single dark matter particle will tap softly against their instruments, like a knock on a faraway door. But perhaps the most beautiful thing about dark matter is what it gives us. In the early universe, when everything was a warm, glowing fog, it was dark matter that gathered the first particles together, its gravity gently pulling matter into soft clumps, like dew collecting on a spider's web in the early morning. Those quiet gatherings became the first stars, the first galaxies, and eventually, the long chain of events that led to suns, to planets, and to us. In a very real sense, the invisible hand of dark matter shaped the home we live in. Without it, the cosmos would be a thin, scattered mist. No spirals, no starlight, no one to look up and wonder. Astronomers have even learned to see this hidden architecture directly. When light from distant galaxies travels across the universe, it passes near dark matter, and the gravity of that dark matter bends the light, ever so slightly, the way still water bends what lies beneath its surface. By mapping those gentle bends, scientists have drawn maps of the invisible, vast, delicate threads of dark matter stretching across the cosmos, and along those threads, like beads on a necklace, the galaxies glow. So tonight, as you close your eyes, picture it, a universe far larger and softer than it appears, where glowing galaxies rest inside great invisible cradles, where unseen threads hold everything in a quiet, patient embrace, and where the greatest shaper of the cosmos is something we have never once seen, only felt, in the slow and graceful turning of the stars. The universe keeps its gentlest mysteries in the dark, and in that darkness, everything finds its place. Rest now and drift, like starlight, into sleep. Hello there, come in, get comfortable, and let your shoulders soften. Tonight, we're going to drift back in time, further than any of us could ever travel, to witness the very first light the universe ever made. This is the story of the cosmic microwave background, the universe's oldest, softest glow. Let's begin, as all good bedtime stories do, at the very beginning. About 13.8 billion years ago, the universe began in an extraordinary burst of expansion. But try not to picture an explosion. Picture instead something gentler, like a deep breath. Space itself unfolding, stretching, growing warmer and denser than anything we can imagine. In those first moments, the universe was a sea of glowing energy, a place far too hot for even atoms to form. For hundreds of thousands of years, this young universe remained a kind of thick, glowing fog. Light itself could not travel freely. It would bump into loose electrons, scatter this way and that, like sunlight struggling through a dense morning mist. Imagine being inside that fog. Everywhere you looked, a warm, bright haze in every direction, with no clear shapes, no stars, no distance, just a soft, endless glow. And then, slowly, the universe began to cool. As it expanded, it calmed, the way a bath cools when left to rest. After about 380,000 years, the temperature had dropped enough for something wonderful to happen. Electrons and protons, drifting separately all that time, finally joined together to form the very first atoms, mostly quiet, simple hydrogen. And when those atoms formed, the fog lifted. All at once, light was free. The scattered glow that had been trapped since the beginning could finally stretch out and travel across the universe, unbroken. That first light, that gentle release, is what we call the cosmic microwave background. It is, quite literally, a baby photo of the universe, taken when it was only a tiny fraction of its current age. Now you might wonder, if this light is so old, how can we still see it? Well, that light has been traveling ever since, and as the universe continued to expand, that light stretched along with it, its waves growing longer, softer, cooler. The brilliant, white-hot glow of the infant universe faded into something far more gentle, microwaves, faint, cool whispers of light, reaching us now at just a few degrees above absolute zero. The universe's first shout became its softest lullaby. For a long time, no one knew it was there. Then, in the 1960s, two scientists named Penzias and Wilson were working with a large radio antenna in New Jersey. No matter how carefully they adjusted their equipment, they kept detecting a faint, persistent hum, coming equally from every direction in the sky. They checked their wiring. They cleaned away pigeon droppings from the antenna. Still, the gentle hum remained. It took some time to realize what they had found. They were listening to the universe's first light, still whispering across billions of years. Since then, we've sent delicate satellites into space, named Kobe, WMAP, and Planck, to listen more closely, and what they found was beautiful. The cosmic microwave background isn't perfectly smooth. It has the faintest variations, tiny ripples of warmth and coolness, like the surface of a pond stirred by the lightest breeze. Those ripples were the seeds of everything. Where the glow was a touch denser, gravity slowly gathered matter over billions of years, gathering. Until stars ignited, galaxies spiraled into being, and eventually, planets formed, worlds like ours. Think about that for a moment as you settle deeper into your pillow. Every star you've ever wished on, every galaxy photographed by our telescopes, grew from those first, faint ripples in the universe's baby light. You are connected to that ancient glow. The atoms in your body were forged in later generations of stars, but the pattern of it all began in that soft, primordial haze. And here is perhaps the most peaceful thought of all. That first light isn't just in old photographs or distant memory. It's here, right now, all around you. It fills every corner of the sky. It passes gently through the room where you're resting. A small fraction of the static on an old television screen was actually this ancient light, arriving after its 14 billion-year journey, just to reach this moment with you. So as you drift off tonight, imagine it, a quiet universe cooling and stretching, a fog of light slowly lifting, and a soft glow beginning a journey so long that it arrives, still gently traveling as you close your eyes. The universe's first light, still keeping watch, still whispering its slow, patient song. Rest now and sleep well beneath the oldest light there is.